to 900 have logged on. Distinguished speakers from
for students, they that I have seen.
Yeah. Ramchandra.
Planning one more at
No. I think 2 days is really good enough.
Yeah.
The thing is that
it is 5 o'clock already.
Yeah. It's when you are ready, we are ready.
We are ready, sir. Here.
Yeah. Please go ahead.
Special thanks to Krishna Reddy, sir, and for waking up so early.
No problem.
Sir is ready to join at 4 o'clock also, which is on YouTube. Yes. Respected Professor K. Umameshwar Rao, President of today's function and Director of National Institute of Technology, Karnataka, Surathkal. Today, who have joined us live on MS Teams and many who are watching live on YouTube. One and all, everyone, good evening for joining us this today's international webinar on opportunities for higher education. The success of the event. And a special prayer is required to make a webinar success for a stable internet connection to all of us. So we'll start with a simple prayer. May I request you to stand for a while. Thank you. With the kind permission of our president of today's function, Dr. K. Mameshwar Rao,
Yeah, please.
let me briefly explain or introduce the webinar to all the audience. As the saying goes, an idea will change the life. Similarly, a proper guidance at correct point of time will definitely change our career. Based on this single point of agenda, this webinar is being planned. 15-20 years back, or maybe more, when we were students, any information, either it should be in a book or a journal, or it should be told by our teachers. We studied in the era of insufficient information, especially about higher education. Today, lot of information is available, but it has become a tough task to extract the correct information. In this regard, NIT Surathkal in general and Department of Mining Engineering in particular has been at the front end to guide the students in forming their long-term and short-term goals. In fact, in the recent past, in the first week of March 2020, we have made an annual convention only for students. We have received overwhelming response where the students have joined physically from different parts of the country, where, as you know, the Mangalore is at a corner of the country. And the feedback they gave us made us to realize that such programs are required in coming days. In India, it is not a common practice to have a separate session exclusively for students in major conferences like in other countries like SME or ISCE. These things, there will be special sessions, but in India generally such is not a very common practice. I think this is the time in every major event, in every international conference or a national conference, we should have a separate session for students who are the future of our industry. Though the pandemic has disturbed everyone's life, but it made the concept of webinar more familiar. In fact, I will be attending a meeting of consortia of a few NITs and a couple of IITs with Australian universities. We are meeting every Saturday at 1 p.m. to discuss the research interests of each others and proposing of mutually interested projects and other professional activities. In the same way, we thought we should do something for the students. At the same time, Dr. Manoj Khandelwal from Federation University also came forward to do this webinar jointly with NITK and Federation University, Australia. The moment we floated this idea, when I spoke to director, he readily agreed, but we were not sure what would be the response from the students. But the unexpected response, just now I have gone through around 882 people have registered. So almost touching 900 people, not even one quarter of this, I did not expect the day we have floated this idea. I am very much thankful to each and everyone who has registered for this. So it is not possible to put 900 people on a live interaction. So we are streaming on it on live on YouTube. All the participants can put or post the questions on YouTube. Our students, volunteers will copy and paste those questions in the chat box of MS Teams so that the speakers can answer simultaneously as good as it is a live mode. I am very much thankful to our director who readily agreed for organizing such a webinar. He has taken since beginning. He has been asking me what is the updates. So thank you for your encouragement, sir.
Thank you.
I have contacted number of speakers around the world from US, Australia, and especially the European countries. Though universities are very old, we are not yet fully explored with respect to mining engineering. So I added a speaker from European countries also. So no speaker has said no. Everyone told it is for the students. We must do. I am there for you. So all the 12 speakers I have contacted, all 12 have agreed immediately, both from India and abroad. In fact, I have confidence now even to extend one more day, though it is not possible at this moment. So we have speakers from IITs, NITs and foreign universities, foreign industry. So with a combination of different research backgrounds from different academic institutes with a good combination. So I am sure the people who are attending this will definitely get benefited using this. A big thanks to Professor Krishna Reddy, though I will introduce him separately, for joining us so early morning. For him it is 6:30 a.m. in Chicago. So I am sure every one of us who is attending this will get benefited, and all the participants will make use of it. Though we are streaming it, we'll be saving these videos in YouTube, but when you are on live, it will be easy to directly interact with the speakers. So with this brief introduction to the webinar, it gave more responsibility for NITK and to the Department of Mining Engineering to think over about the students further, which will make us, or which will give a greater responsibility for us to plan such activities in future. My intention is changing a working professional, whether a teacher or a professional, it's not so easy, but changing the shape of the future of the students is easy. So that has been our focus. Definitely we will focus on this. Especially this is aimed to create awareness about higher education and research students of mining engineering and interdisciplinary areas. I have seen many students have registered civil, geotechnical, environmental, industrial pollution control, geosciences, geophysics, with a different academic background, not only from India, a few from other countries. I'm extremely thankful to each one of them who have joined us, and they gave a big support to attend this. In the recent past, hope you are all aware that in India, many new mining departments have been started in different states. Though a number of departments have started, they have not well exposed to research and academics. I am sure there are very bright students, even such institutes. They might not got into NIT, IIT within 1 or 2 marks. It does not mean that they are lower ranked students. So our focus, being the only NIT offering mining engineering department in South India, we thought we should take a lead to help and guide such students sitting at NITK Surathkal. As head of the Department of Mining Engineering at NITK Surathkal, I assure all such students, whatever the professional help you need, we are ready at your convenience, whether online, offline mode. We will be helpful to that. I promise to all such students, to the departments, to the faculty, everyone, we are always take it as a responsibility to help you, to guide you. Even one student get benefited out of this in their future, we will be extremely thankful. With this brief introduction, now I move on to the further proceedings. Now I request, before I request Professor Krishna Reddy to speak a few words. In fact, his session is there at 6:35, if I am correct. Let me briefly introduce Professor Krishna Reddy. Professor Krishna Reddy does not need any introduction. In an international scenario, coming to geotechnical and geo-environmental engineering, he is a well-known figure. But for a few mining engineers, he may be new. So let me introduce in brief. Professor Krishna Reddy graduated in civil engineering from Osmania University, Hyderabad. He was a class topper of 1983 batch and a gold medalist. Later he moved to US and obtained his MS and PhD degrees, PhD from IIT, that is actually Illinois Institute of Technology. I also got confused in the beginning. In short, it is called IIT, but Illinois Institute of Technology. And presently is a professor and university scholar, distinguished researcher, and director of Sustainable Engineering Research Laboratory, and also director of the Geotechnical and Geo-Environmental Engineering Laboratory at University of Illinois, Chicago. Dr. Reddy has over 28 years of research, teaching and consultancy experience in the broad fields of civil, geotechnical, materials, environmental, sustainable, resilient engineering. He has published 5 books in the areas of environmental remediation, solid and hazardous waste management, characterization and engineering applications, life cycle assessment, and geotechnical engineering. He has projects into worth of millions of dollars. It is very difficult for me to list out this. Actually, in fact, this students must have already googled the profile of each individual. If a B.Tech student has to go through his profile, it takes 1 hour. To understand, it may need a day. So I am giving only brief details. He has published more than 240 journal papers, edited 21 books. Just now I was going through his Google Scholar citation. Exactly, it is 12,335, if I am correct exactly, which is remarkable achievement, which is not an easy task. Okay. So he has several awards and excellence in research and teaching, like ASC, American Society of Civil Engineers, Wesley Horner Award, ASTM Award, UIC Distinguished Research Award, University Illinois Scholar Award. So the list goes on. Above all, it is all there. It is on his web page. I had a very close interaction during my stay in Chicago for almost a year. Above all, is down to earth person, where he will be available at our convenience. If I text, immediately he will reply. If I send, immediately he will reply. So it is not. I thought it is easy. It is not easy to talk to such a professor, but I am extremely happy. And in fact, among his 270 papers, I am happy to say I have 3 papers with him, joint author, and 1 book chapter, which is just published last week only. We have worked together for some time. I am extremely thankful to you, sir, for joining us. I am sure through this webinar, at least one student will get an opportunity to work with you in future. With this brief introduction, I request you to speak a few words.
Yeah. Good morning, everyone in the US. Good evening, everyone in India. Thank you very much for that wonderful introduction. First of all, I hope everyone is safe, and I hope everyone is watching this webinar from a safe place. I hope you are not driving and watching it, or you are not in a public place, at an unsafe place. I hope you are in a safe position to watch this one. So please, be safe. It's better to be safer than, being sorry later. First of all, I want to thank Dr. Ramchandra Karra for organizing this, and also co-organizer. I want to thank Dr. Manoj Kandelwal. And of course, without the blessing of NITK director, nothing can happen. So I also want to thank Professor Uma Maheshwar Rao for, encouraging, for organization of this webinar. And I'm, glad to be invited to be part of this webinar. And, this is an excellent webinar. As I was telling before, we have a wonderful lineup of speakers. I was looking at it, all the speakers are eminent speakers, and they're talking about a lot of different topics of, emerging importance. And also, the program is oriented towards students, which is very unique compared to other webinars. As you all know, there are so many webinars these days, and most of them are highly technical seminars, but this is being oriented towards students, which makes them easy to understand what are the future career opportunities are in mining and related areas. So in that respect, I highly commend the organizers for organizing this unique seminar. I visited NITK 2 years ago, beautiful place. In my presentation, I will show you a couple of photographs that I took when I was there. Excellent facilities. I had an opportunity to visit mining engineering. I visited the lab, and I came to know about all their very, large, very impactful projects. A lot of them are being done in the field, so that was very interesting. I came to know Dr. Ramchandra, as he was saying. I met him first time when I visited NITK. After that, he spent almost a year with me. I got to know him so well in terms of his technical interest, in terms of his, capabilities. He always wants to do something new, especially, I know he's the expert in rock blasting, but he also has expertise in waste management and slope stability, which are very dear topics to me. I work in geotechnical and geoenvironmental engineering area, not directly in mining area, but there are many things that I do could be applied to mining areas, mining engineering. So, you will see in my presentation, I can present few ideas on what can be done together. Especially the waste management and waste utilization is a hot topic. And there are other, many common areas that the geotechs, civil engineers and mining engineers can work together. I can foresee, good collaboration, myself or, all these foreign speakers, they're all, excellent in their own research areas. So hopefully we can, collaborate more and make NITK, much more visible in the world scenario. And I know, there is already close collaboration with civil engineering at NITK. I see Dr. Ramchandra advises a lot of Ph.D. students from civil engineering. I mean, he's the ghost advisor. I think, he does all the advising, but they get the degree from civil engineering, not mining engineering. But I understand he's doing a lot of things to make NITK more visible. I understand he's, appointing adjunct faculty, is, taking on a lot of online programs. So hopefully, all those will help expand the Department of Mining Engineering at NITK. So I am glad to be part of this program, and I look forward to, listening to all the presentations. So thanks again for the opportunity to be part of this program. Again, I want to thank the director and I want to thank the organizers for inviting me to be part of this program. Thank you very much.
Thank you, sir.
Thank you very much, Professor Krishna Reddy, for joining us. After a few minutes, again, we'll start your presentation. Yes, sir. I would like to inform everyone here, Professor Krishna Reddy readily agreed, gave his consent to be the adjunct faculty here, but it is under processing. Soon, I think we'll do that. Director, sir, may give some more details. And we have initiated many new initiatives, sir, in the recent past in the department. We are going and expanding the department in various dimensions. Many are at a very initial stage, and we need the help and blessings of many people like you. Your cooperation is required to see that this department will come to an international mining fraternity map. That is our objective within next couple of years. First time we are also planning a program, especially for industry people on online mode. So that is actually very welcomed by Singareni College top management, and that will be fruitful. Over a period of time, we'll work together, sir. I'm sure your help and blessings will be there for us always. Thank you for your kind words, sir. So actually, we have put the session very small. Many guests have joined, like Professor Debashish Dev from IIT Kharagpur, Mr. Amarnath, retired CGM, Singareni, and many others. But now, before asking the president of today's function to give his remarks, let me briefly introduce. Most of us know him very well. Professor Uma Maheshwar Rao Karanam, or known as Professor K.U.M. Rao fondly by his students, is a graduate of mining engineering from Osmania University, same 1983 batch, if I am correct. The guest and the president are contemporaries in university days. After working briefly in industry, he joined IIT BHU presently, a former IT BHU for masters, and stood at class first with a CGPA of 9.38 on 10. Professor Rao started his teaching career in this department where we are sitting today as one of the founder faculty in those days, in the year 1987, as a lecturer. After that, to pursue his career at IIT, he moved to IIT Kharagpur. Then after 30 years of career, he came back as a director of NIT Surathkal. We are extremely proud happy for this, and always we feel he's part of mining department first, then the director next, because he started his career with the mining department. So at IIT Kharagpur, he held various positions, including head of the department 2 terms, and he was vice chairman of IIT JEE and Trends. Professor Raw's field of specialization is experimental rock mechanics and has been working in this area since 1989. He has produced 6 Ph.D. degrees and 12 more are at advanced stage of completion of their thesis. He has published number of papers in national and international journals, completed number of projects. Maybe due to his administrative responsibility in the recent past, he may not be taking a research projects. And especially students are fully aware about his book on principles of rock drilling, published by A.A. Balkama Publishers, Netherlands, which is later published by India Book House, New Delhi. Even today, as per our NIT mining engineering curriculum, there is a subject called drilling and blasting engineering. The drilling portion, his book is being referred. Professor Rao has obtained INSA KOSF, that Korean Science and Engineering Foundation Award. Under this fellowship, he worked at Korea Institute of Geosciences and Mineral Resources in 2003 and 4. Later, he was also awarded Erudite Fellowship from South Korea in 2005. And he was also visiting professor at Chonnam National University, South Korea in the year 2008. Served as a professor in the Department of Energy Resources Engineering at CNU in year 2008 and 9. During his long association with South Korea till 2002, he was invited on various occasions for delivering lectures in Seoul National University, Gyeonam National University, and Kongwon National University. He was also invited by the University of Adelaide, Australia, for delivering lectures in mining engineering. Later in the year 2015, he was appointed as visiting professor in the University of British Columbia in Mechanical Engineering Division. After almost more than 3 decades of span of experience, in the year 2017 June, he joined us as a director of NIT Surathkal. So, being a core mining engineer, a well-known researcher, he follows every activity closely, and of course, mining community or mining fraternity knows him very well. So, I request you to speak on this, sir, not only as a president of this function, as a core mining engineer, to guide the students, because as a director, I don't want to put you as a separate session for you, because I understand your busy schedule and so many meetings you had to attend, sir. It is time for you, sir, to speak.
Yeah, thank you, Professor Karra Ramchandra. Honorable Chief Guest of today's webinar, Professor Krishna Reddy, distinguished speakers, and then distinguished invitees from various industries, faculty members of the department across the globe, the students of NITK, as well as the students from other institutions across the globe. A very good evening to all of you from India, and greetings to people from Australia, because it must be around 9:30 in the night, and a good morning to all from USA. At the outset, I want to thank the organizing professors, Professor Karra Ramchandra, convener, National Institute of Technology, Karnataka, and Professor Manoj Khandelwal, co-convener from Federation University, Australia. I'm extremely happy to note that there are many distinguished speakers from USA, Australia, Zambia, and also distinguished speakers from various IITs, NITs, NIRM, and from few industries in Australia as well, and then Minister of Environment and Forest, Government of India. It is heartening to know that around 900 people have logged on in today's webinar. Probably it is because of the topic, and as well as because of the spread of the spectrum of speakers we have, and which we will be seeing that the topic will be unfolding on the vision for mining education and research, and indeed the topic is topical also. I earnestly wish that mining engineering education also adopts all the necessary requirements to become one of the top 5 disciplines of students' choices in the years to come. Today's the topic, as all of you know, that it is about the opportunities for higher education and research in mining engineering and interdisciplinary areas. I wish to really go around the topic word by word, as well as go into the between the lines of this particular topic, because I wish to address the students, the speakers as well. They will be giving their opinion about this particular topic, and then about the preparedness of the educational institutions for the future of mining education and industry together. Before that, I just would like to really remind you that ever since the national education policy was unveiled on 7th of August, we at NITK are drawn ourselves onto the anvil, shaping our thoughts to transform the professional education into a multidisciplinary education and research university, which is popularly today known as MERU. Towards this, we have been sharing opinions from many scholars, technocrats, policymakers for over a week, and the topics for discussions were wide ranged, from a need for what exactly is the need for a new education policy to advances in research scope and challenges in power electronics. Later on, and in the last few weeks, we did shift the line of sight to full 360 degrees, and we did set the virtual stage, inviting scholastic opinions across the oceans on interactive design in geotechnical engineering. That particular webinar is still going on for 9 days, and then around 60 participants from 60 countries have registered, and then the strength of the participants is about 2000 plus. And today we have gathered, and the number is also sizable, comparing the mining fraternity on the topic which is opportunities for higher education and research in mining engineering and interdisciplinary areas. As a teacher, I would like to really make certain critical observations, and I have been a very strong critic of my department at NITK as well. The intention of giving my criticism or the remarks of criticism is to let them grow to bigger heights. Opportunities for higher education in engineering per se are directly linked to the learning outcomes. We cannot ignore that particular learning outcomes, which in the sense is the opportunity of employment. Therefore, focusing on learning outcomes are indeed the key to the meaningful education.
Voice is not clear. Voice is not clear.
Hello.
Voice is not clear.
No, it is clear, sir. It is clear.
Okay.
Right. Now it is okay.
Yes.
So the perception of the industry remains and reminds that the graduates enter the industry with a narrow view of engineering and related disciplines, have weak soft skills, are to be very critical, little skills, lack team spirit for being taught to work as individuals, lacks accountability, and shun from taking the responsibility. This is the general remark of the industry today. With the rise of National Education Policy 2020 on the country's horizon, it is recognized that skills and human capital are the backbone of economic prosperity and then social well-being. In the present knowledge-intensive economy and then society, individual and societal progress is increasingly driven by technological advances. In order to remain afloat, it is essential to retain the competitive edge by all and one and all. And what exactly are the thrust areas are developing and sustaining a skilled workforce, maintaining a global competitive research base, and improving the dissemination of knowledge for the benefit of society at large. In this context, higher education represents a critical factor and plays a central role in the success and sustainability of knowledge economy. There has been a historic debate on whether mining industry is innovative or not. Most of us think that it is a conservative sector where innovation takes place only at these secondary positions in the concerns of the companies. But things are changing fast. Mining industry is at the inflection point. Most of the mining engineers understand what exactly is the point of inflection or inflection point in which digital technologies have the potential to unlock new ways of managing variability and enhancing productivity. Nowadays, many in the industries too claim that mining is going through the first stages of deep changeovers from the hand to digital transformation. That is, from human run operations to autonomous or semi autonomous remote controlled machines. Very soon, we may see that the manual mines where hand shovels and all they become the examples of the past. And Professor Devashish Dev is going to talk on the digital transformation, which is already impacting the industry and will continue doing so. Nowadays, the world is changing faster than ever. New technologies are developed every day, impacting the way people are living, and at present, expecting or imagining a person without a smartphone is something which is improbable or very difficult to imagine as well. A major technological shifts is occurring across the industry. The so-called fourth industrial revolution, or simply industry 4.0, as the transition at the digital era. Then social environmental concerns are already compelling mining industries to look for safer, more efficient and sustainable ways for conducting the business. Reduction of water and water consumption, lower emissions and waste generation are all factors that will be the core of the mine of the future. The frontier areas, here I just now would like to speak about the frontier areas and which indirectly are the opportunities for interdisciplinary research and then mining education. First one is the automation, robotics and remote operations. These technologies might hold the highest level of implementation among the tools offered by digital technology. We will be hearing in details in the subsequent days of the webinar on digital technology in mining industry. Analytics, artificial intelligence, machine learning, and big data analysis. Analytics and intelligence. Advances in analytics from machine learning to improved statistical techniques for integrating data, which help turn vast data sets into insight about the probability of future events. Internet of Things. Again, it is IoTs, smart sensors, real-time data capture. IoT is understood as a network of physical objects such as sensors, equipment, machinery, and other sources of data. The elements connected to this network can then interact, exchange information, and act in coordinated way, like the human to machine interaction, digital to physical conversions. Advances in robotics are making equipment that is fully autonomous and more affordable and effective. Fourth one is the power electronics. We had a detailed webinar also a few days ago, and it is all about the generation of power and the electronics which is embedded with that one. And we all know that around 68% of the power that is generated in India is from burning of fossil fuels, and around 3 to 4% of the power is generated from nuclear resources, and the rest is all from the other resources. Now the environment has become a greater issue, and therefore in that scenario, power electronics is also going to play a major role with the advent of electromobility as the development and use of electric powered vehicles. And then from the personal use cars and private transportation vehicles to heavy machinery, electromobility offers an economical and more environmental friendly alternative to the use of fossil fuels. Fifth one, which is very dear to all the mining engineers, which is still in the same conventional modes, is about the zero waste mining. Underground operations have been using their waste materials to backfill open cavities, which are left after the ovary is extracted. And it has been mainly for the stability reasons and as a means to reduce the haulage cost as well. And rehandling cost also is going to be reduced by that one. And then at IIT Kharagpur, and then research efforts are on about the paste backfilling in the hard rock mines. So now this in practice is going to reduce the subsidence effects, and therefore the impact on the surface above the ground is going to be minimal. That is the philosophy and then objective of zero waste mining, and which is going to become mandatory in the years to come for the industries to realize. Continuous mining, this is again not a new area for mining engineers, but then it was initially, or rather it is still restricted to the softer fossil fuels extraction. But then of late, the scope of technology has increased in the softer and then medium hard rocks. And then we see that a lot of tunnel boring machines are being used for the within the continuous mode of rock excavation. And then the seventh one is that interactive designs. Interactive designs in geotechnology, geomechanical or rock mechanical planning, which is of the future. And on furthering the areas of interdisciplinary education and research include, now we just have to realize, Professor Krishna Reddy was also mentioning about this sustainability, right? The need for integrating sustainability in our academic culture for education and research development has become essential. And there are many questions about that one, many queries which we need to answer to make the sustainability a part of our life as well, from the institutions to the industry. And those questions are how the institutions may respond to the increasing awareness of social as well as environmental responsibilities, right from designing, planning, developing, operating, and closing the mines as well. Mine closure at one time was not a mandatory, but then about a decade and a half ago, it has become mandatory. And then the standing example of the hurdles which the companies are facing is the Kudurmo Kainur company. At one time, it used to be a very big company in Asia. And second question which we need to really think seriously about is what learning models could facilitate the capacity of our mining faculty to legitimately lead sustainability teaching and research initiatives. The beginning has to start from the teachers, and it has to percolate into the industry through the engineers or the graduate engineers who join the industry. So now, what exactly is the preparedness of our teachers towards this one? The last question which I have here is that what interdisciplinary networking mechanisms could serve the need for educational and research development within the context of our institutions? These are the three major questions as far as sustainability of mining engineering per se is concerned. Now, coming to the Indian context, the mining industry and mining educational institutions, please don't take me wrong, right, probably have been slow in reacting and adopting to the digital technologies and then the trends of the digital technology, because we are still to see the applications of digital technology are all the topics which I have really mentioned earlier, right from the artificial intelligence. Maybe we just have the little bit of neural networks, but then big data analysis and then various other points which I have really stated, which I don't want to repeat them again. They are not seeing as the subjects or the electives in a big way and preparing our students. That is what exactly is what I meant about that one. The academics must take the leadership in creating the sort of professionals and services and research that will help the industry adopt the new technologies at ease. There should not be any hitch about adopting the new technologies through the involvement of the institutions by the graduates who join the industries. Professors, researchers, and then students, they also need the assistance from the mining industry, right? And then I think there is a visible gap between the mining industry and education institutions as far as the setting up of the curriculum is concerned. That gap has to reduce if we have got to realize some of these particular observations. In technological context of the industry, which is now at 4.0, the goal of an educational leader is to respond effectively to the changing learning styles. This is about the teaching and learning styles by implementing virtual and augmented reality. Teaching as a facilitator, not as a person, right, who is just trying to give away their notes. Things very soon the things are going to be a past, and then the teacher needs to be a facilitator and supporting group work. This is very important as far as the acceptability of our young graduates in the industry is concerned. Gone will be the days when a student will be saying that I want to work as an individual, not as a member of the team. We have got to inculcate the team spirit and then support the working in group, providing case studies in the real world. That should be the part of the educational skills that we are trying to develop to the students, and teaching through physical activities rather than listen to a lecture. A lecturer or if a professor is speaking and then the students are on mute and listening to them, that will not going to really last for long, because it is going to be kinesthetic learning methods are going to really come up very soon. The educational policies are thus from the basis of establishing latent strengths of human resources of tomorrow. Competencies imposed by new technologies will reshape the labor market as we know it. Today's students are continuously connected through the advanced technologies. It is not the same old conventional mode in which the students are going to be, and then they are connected to the advanced technologies and social networks. The education sector needs to respond to this, adapting curricula and strategies to address the challenges and opportunities posed by this change. Everybody is aware that we are passing through the millennial generation, and it is a generation which is globally connected, in which people communicate in the virtual environment, and the industry equipment also communicates in the virtual environment. And then today we are meeting in a virtual platform, Microsoft Teams, right? It has become the reality. As I was telling our chief guest, Professor Krishna Reddy, that it is no more the virtuality is the reality, and that exactly is going to be tomorrow, and then even after COVID times. IoT as a technology opens the possibilities of creating sustainable economic growth, if and only if educational policies will manage to ensure the competence of Generation Z to communicate with the people and industry equipment with the same ease. This Generation Z or Gen Z are the generation which are true digital natives, in the sense that their early youth is in digital era. They have been exposed to the internet, to the social networks, and to the mobile systems as well. With the industry 4.0, with the students belonging to Generation Z, and if the educational sector remains unmoved, remaining conventional, the intra-sector gap is likely to just widen and visible. It is therefore essential to address the expectations of new generations while finding an appropriate response to the challenges of the new technologies which the industries are expecting. The teachers need to prepare for a total transformational shift from the content-based teaching to creative and competency-based teaching or learning. Right? It is not, nobody is now going to look at the how much is the content that we have really dumped on the students. Content is available on internet. Now it is going to be how creative, how much have we really able to inculcate the creative thinking, and how much have we really made the student competent through the learning process is what is the most important one. It is imperative that success story of creating opportunities for higher education and research in mining engineering and the interdisciplinary areas depends on how we the teachers navigate in the years to come. Every word in the today's topic is absolutely very, very apt to the conditions which we are passing through. Opportunities in mining engineering, opportunity, not only that, higher education in mining engineering, research in mining engineering, and then interdisciplinary research in mining engineering. Every single word in its own has a meaning to the mining engineering education. And then the students who are now trying to look at the mining engineering education, I earnestly wish that we, the teachers and then industry, come together, all the stakeholders, right, at the decision making, the policy makers also come together and then try to redefine what exactly is the need of the industry. Industry has already entered. Mining is not anyway behind. Mining industries is also already has entered into industry, the industrial revolution 4.0, and therefore, right, all our curriculum has to really redefine, and then those the subjects can which needs to be dumped in, they are available on internet. Those subjects which are not already there needs to be introduced in the curriculum to make mining engineering one of the choices, the best choices for the students. Once it was asked to Albert Einstein, it seems he said that if I were given an hour to save the planet, I would require 59 minutes to understand the problem, right? And then defining the problem. And then thereafter, after understanding and then defining the problem, he said that he needs only 1 minute to solve the problem. And therefore, right, we the teachers have understood what exactly is the need of the hour, and the success of the entire mining education. It is not going to end by this particular webinar. It is going to be the beginning of what we want to be tomorrow, and where do we want to take the mining engineering education to the generations to come. Thank you very much, and back to Professor Karra Ramchandra.
Thank you very much, sir. You have touched all the points. In fact, it is become a summary. The same points are being deliberated by the speakers as per the schedule given to us. Definitely, the Department of Mining Engineering and ITK Surathkal, under your guidance and advice of many people like Professor Krishna Reddy, will take ahead, sir. Dr. Manoj Khandelwal, a formal vote of thanks you can propose with if you want to add 1 or 2 points, so that we can start the session. So formally, we'll close the inaugural function. Dr. Manoj.
Thanks, Professor Ramchandra. Good evening, distinguished guests and participants from Australia. It gives me great honor and it's my proud privilege to propose a vote of thanks on this occasion. I, on behalf of National Institute of Technology, Karnataka and Federation University, Australia, and my own behalf, extend a very hearty welcome to all the participants. First, a very big thank you to Professor K.U.M. Rao, Director, National Institute of Technology, Karnataka, and President of today's event for delivering the presidential address. I would like to express my sincere thanks to Professor Krishna R. Reddy, University of Illinois, Chicago, and today's function chief guest for attending and delivering the inaugural speech, and who will be delivering a speech on geotechnical and geoenvironmental engineering research in a short while. I would also like to give my sincere thanks to all the distinguished researchers, academicians, and student participants who have been attending this webinar from the different parts of the country and abroad. An event like this webinar cannot happen overnight. The wheels started rolling weeks ago. It requires planning and a bird's eye for details. We have been fortunate enough to be backed by a team of very motivated and dedicated staff of National Institute of Technology, Karnataka, who perform their job efficiently and effectively. I would like to express my sincere thanks to them also. Last but not the least, I would like to thank all those who have directly or indirectly helped us for the successful execution of this webinar. I thank you for being with us this evening. It's been a great pleasure having your presence at this webinar. Thank you for your attendance and support. Thanks.
Yes, thank you to you also, Dr. Manoj. We have done this first international activity jointly from the department. If it is late night, you can log off. Hope you will be joining tomorrow morning along with your dean as the guest.
Yeah, it's already near about 10:30.
Yes. Yes, we are already behind schedule. My request Professor Krishna Reddy to make his first presentation among the speakers on research opportunities in geotechnical and geoenvironmental engineering, sir. You may slightly need to reduce your time, I think. As already I have introduced the guest, I am not going into again another formality again. Over to you, sir.
Sorry, I was muting. So can you see my screen now? Ramchandra, can you see my screen?
Yes, we can see.
Yes, it is very clear.
Oh, okay. So just wanted to make sure because I was muting it. See, I'm sorry. Okay, so just need to find out where is. Sorry for difficulty. Not able to see the presentation that I put it on. One second. Coding this. Okay. Shared window. Paused until it returned to the shared window. Okay. Can you see my? Sorry, I have a problem with the
Your Gmail is visible, sir. It is not PPT.
PPT. So let me just go into sharing. Okay, now, sorry. We are used to using Zoom, so not this one.
Yes.
So just, yeah, okay. So I'm going to make my presentation very brief. Again, thanks a lot for inviting me for for this webinar. So what I'm going to do is I'm going to just give some perspective from my own research point of view. I do research in geotechnical and geoenvironmental engineering, and how it could be related to mining industry. I know Dr. Rao, the NIT director, has given a big picture of where we should be going, but this could be a little bit more focused, on solving the problems, currently that we have. So again, I want to thank Dr. Ramchandra Karra and also Dr. Manoj Kandelwal for inviting me. Again, Dr. Rao for allowing this webinar to be organized. And I want to thank all the attendees for attending this webinar. So just quickly, 2 years ago, I had a pleasure of visiting NIT cave for the first time. So this is the Department of Civil Engineering. I can see Dr. Ramchandra right there in the back. So that was a really nice time. And I gave a presentation to the AACE student chapter there. And of course, you cannot, you cannot visit NIT without, you cannot say that, your NITK visit is complete without visiting the beach, right? So I happened to be in the beach. And then, of course, Mangalore is a nice place. I visited the temple, and the best, dinner I ever had was in Mangalore. So, Dr. Ramchandra has pointed out that, he spent almost a year with me. And that time he gave a presentation, very interesting presentations he gave on rock blasting. A lot of civil engineering students never heard about those kind of presentations. It was fantastic. And we were able to, discuss about the research and as Dr. Ramchandra has pointed out, we continue to do research, and even as of today, even we are trying to work together on a lot of issues related to mining and waste management, and mainly towards achieving zero waste issue. So if you haven't been to Chicago, I welcome you to visit Chicago, especially in the summer. So it's a nice place to visit. This is my campus, University of Illinois at Chicago. It's really walking distance from the downtown, so it's a nice place to be in. So you can enjoy the cities and at the same time enjoy your career. In my lab, I'm in charge of two labs: Sustainable Engineering Research Lab and the Geotechnical and Geoenvironmental Engineering Lab. I do a lot of research on environmental remediation of soils, sediments, groundwater, and stormwater. I mainly deal with in situ remediation technologies that are contaminated soils and rock, groundwater, sediment, contaminated with different types of contaminants. So we work on developing new technologies or integrating the technologies, optimizing the technologies. Right now, our focus is more on green, sustainable, and resilient remediation technologies, how we can achieve those things, as compared to in the past that we didn't pay attention to the sustainability. So other area of interest is waste management and landfill engineering. This is very much in line with my interest with Dr. Ramchandra. Beneficial use of waste and recycled materials, and any kind of a biological treatment. And at the end, if you don't have any choice, if you have to landfill it, how do you engineer the landfills, and how do we make even those systems more sustainable, and make them part of a circular economy. And I work on life cycle assessment and sustainable and resilient engineering. My focus is more on developing sustainability analytics, developing the tools to quantify sustainability. So if you have such a framework, then you can apply to assess, the materials, infrastructure, waste management, any kind of the projects that you have. And recently we have been augmenting sustainability with resiliency, so that we address, the sustainability as well as resiliency also. And I have a lot of my PhD and master's is in geotechnical engineering. I continue to teach and do consulting in geotechnical engineering area. So my research, is more on municipal solid waste, industrial waste, polluted sites. But my experience with mining is not that much. And if I look back, what I did related to mining in 1994, that was a long time ago. I worked on a underground coal mine site, but not underground. But when they bring the coal to the surface, they process it, and the processed coal is shipped in trains, and all the waste is piled up. These are called refuse disposal areas, and they didn't have any preparation, of the ground. They just dumped it, and a lot of contaminants have leached into the soil and into the groundwater. And there are some villages around that area, and also there are rivers around that area. And there was a concern about contamination spreading. So we had to do investigation. So these contours basically show you the groundwater flow in the direction. And then we had to do basically modeling to define the extent of contamination. The whole project was about, establishing the groundwater management zone, and then, take a corrective action to make sure that, you don't extend the contamination beyond the groundwater management zone. So for that one, we had to do a lot of modeling. And then, of course, when you start with modeling projects, you don't have the data. So we have to go to the field and collect additional data. And we had to, calibrate the model. And then we had to predict the, what the contamination, how the contamination would spread into the future. And then, we had to look at what are the remedial alternatives that we have that can really, contain the contamination within the contamination zone. So basically, they were looking at a pumping system, and we need to, optimize that pumping such that groundwater management zone is, contained, not allowed to spread. and what would be the optimal way of designing this pumping system. So that was my the first project that I could think of related to mines. But in 2019, I am a Spark faculty at IIT, ISM Dhanbad. I happened to visit the campus, and they had this, the big building with this long wall model, and it was a really good experience to go in there, in dark and hot and sweaty, to experience what underground miner would feel. You could. This is they use this one as an educational tool, and it was fantastic feeling to look at how underground mining looks like. Then I happened to visit open cast mine, and that opened up my eyes. Because unless you go to the site and see it, you will not be able to understand the real world problems. You can sit in your lab or you sit in your office, think about what should be the good research projects for mining, but unless you go to the field, you will not realize what the real problems are. So this is the site visit we had, and it was kind of a nice. And this is a small video I wanted to show, because the magnitude of the problem, people don't realize it. It's a huge problem, if you look at it. You're dealing with a large area, and a lot of times, the activities are not well organized, and a lot of issues that you can visually see, being an engineer, being a researcher, you can find out what all these different issues are. For example, you can see, these big overburdened piles. As a geotechnical engineer, as soon as I see this, very tall, very high, and very steep slopes, then, I worry about, the slopes are going to stay or not. And then see, when miners are working, you see some fire, gases, and some places there's processed water, and you can see it. So, having never been to any mine site, it was a really eye-opener to look at what goes on in the site. So once you have that kind of site visit, once you have a clear idea about what are the problems, you can talk to the project engineers and discuss those things. And what I'm going to present here is very quickly, from my point of view, some of the things that we have done in geotechnical and geoenvironmental engineering can be readily applied to analyze some of the problems that we see in mining industry. So one of them is the slope stability of overburden dumps. Another one is the beneficial use of overburden as construction material. And other one is the environmental pollution problems, how we can address those things. And at the end, the end use of mine site and how we can make it more sustainable. So, just wanted to point out these things very quickly, because, some of you maybe already worked on this one, this may be too trivial for you. Coming from geotechnical and geoenvironmental engineering background, I find these issues very, very fascinating. So, for example, slope stability of overburdened dumps. So we deal with slope stability on every day. We teach, we do all these things. But a lot of times we deal with soil slopes. And, what I see it is, I try to look at the literature, how these overburdened slopes are analyzed. To my surprise, all the methods that have been reported in the published literature is just like what we do for soils. And as you know, these are not soils. You look at it. This is, I'm looking at the long distance view of how in this overburden looks like, and close-up view of how the material looks like. How can you assume this material that looks like these broken rocks as a soil? That's really surprises me. I looked at the literature, and I found out that there are a lot of failures that takes place. A lot of them may not be reported. Some of them, I just, this is an example of the failures that have occurred, and published. And I was wondering what could be the reasons for these things. Obviously, drainage is the main problem, right? In, all the failures, water is mostly responsible for it. So you have a lot of water accumulation in one case. One case you have just, very high, very steep slope. And in one case, this is often not considered is a fire, So fire and the gases that gets generated within these piles, because some of the materials is combustible and, the combustion takes place. and you have these, excess gas pressures generated. And other places, not designing these slopes properly. You don't have corridors, there's no drainage. So obviously, these are kind of, and also looking at the season, it doesn't matter, it's a summer or, winter or rainy season, these failures keep on happening. So, and as I said, I was disappointed to see in the literature. I'm just showing you as one example, but I have seen, hundreds of papers on slope stability of overburden. They just look at, conventional, soil slope analysis. And other thing that was surprising to me was, the properties of how, these properties were selected. This is an example of it. So, my question is, how were these properties determined? In the field, you saw this, rock chunks, right? Rock blocks, like more like cobbles. And how did you test those things, right? So, I'm surprised that, the friction angles were so low, and probably they processed it, and whatever the material that they could do testing in the lab, they tested it, but that's not totally reflective of the properties of this, rock chunks that we see. And the slope stability methods, they just use the limit equilibrium methods or these, finite element methods, commercial programs that we have. Again, the material is assumed to be like a soil type, which, in my opinion, is wrong. And these kind of things, we can do it, whatever is the effect of slope, what is the, effect of height. And we do these things in our, class projects when we talk about slope stability. So a lot of these research questions came up to my mind. How do we model this overburden accurately? So it's not a homogeneous soil-like material. So the rock fragments, we really need a different approach to model these things. How do we determine the properties of this overburden, right? Sampling, how do we sample it? When we went to the field, we wanted to sample. How do you pick these samples, representative samples? How do we test these things? You don't have a huge lab testing equipment to test these kind of materials. How do we address that one? What is the appropriate slope stability analysis method? Are the methods that are used for soils, are they applicable for analyzing these rock type materials? And how do we address the heterogeneous nature of this overburden? And how to model these environmental factors, which are not, I haven't seen much focus on this. Gas pressures, seems to be a problem. Internal fires is a problem. Of course, rainfall is a big issue. Nearby blasting vibrations is an issue. And some of these are in earthquake-prone zone areas. And how do you address these earthquakes? So we need to incorporate, all these environmental factors into the slope stability analysis. And, what are the best field monitoring techniques to look at this slope stability? I'm glad to see some of the speakers in this webinar have expertise on remote sensing, using, a TDR and that kind of techniques to monitor slopes. But how do you, make sure that these truly can be applied to this overburden? And other thing that, coming from geo-environmental perspective, how do you assess the surface water and how you assess the erosion issues? And also, some of these overburden materials could have leachable pollutants. How do you control that, contaminated surface runoff? So these are, and also, the climate is not going to be friendly to us. As we go into the future, we're going to expect heavy storms or, droughts in some areas. And obviously, these will have, definitive impacts on slope stability. So are we prepared to address these issues? So these are kind of research questions, I try to, pose to the mining engineering community. And we need to do better job on these stability of overburden dumps. And biostabilization, now from sustainability point of view, biotechniques are considered more sustainable. And there are some projects, I was very glad to see, some projects where they implemented biotechniques to stabilize the slopes. And a lot of questions about this one. When you have these, huge blocks, there is no flat surface, there is no topsoil. How do you prepare the surface? What kind of plants can grow in this kind of an environment? What kind of nutrients that we need? What kind of water demand you have? What is the root depth, the density? How much is the increase in shear strength as a result? how the slope stability is going to, impact, and how this minimizes the erosion, gas emissions, and surface runoff, how this kind of, phyto stabilization can, prevent leachable contaminants. Are we looking at this as a temporary solution or permanent measure? As Dr. Rao mentioned, there's a lot of emphasis on backfilling. Is it going to happen sometime soon? So then, in that case, it would be a temporary solution rather than permanent solution. So that's kind of one issue. The other important issue is beneficial use of overburden. If you want to get rid of these piles for some reason, okay, you have no use to some material, and this will be a great resource as a construction material. And as you know, there's a huge demand for materials in construction field. So this is a U.S. Material consumption diagram. As you see, construction industry, construction materials, constitute, large fraction of the material consumption. And globally, these construction materials are going to dominate as a resource consumption. So sand, gravel, and crushed rock is going to be the most dominant material that is needed for construction purposes. And that's where these raw materials, the need for these raw materials could double by 2060. So the demand for this one is going to grow into the future. So in this case, can we use this overburden as a construction material? So what we do is in my research, any waste material that I want to use for beneficial purpose, we go through this assessment process. So you have a waste material. What is the intended application? And then, as I mentioned, any waste material that you're dealing with, the standard testing methods may not be applicable. So you may have to establish testing methods, and then you test the material and find the results and see if it can meet the requirements. And if it does not, you don't want to give up. Is there a way to modify it, material? And if you find it's usable in modified form or it's existing form, is there a need for doing the field demonstration to get more performance data? And then once you have that material tested in the field, you have a material that is approved for intended applications. But then you have to look at a lot of implementation constraints. For example, this overburden is at one location, your construction project is at some other location. So there's a lot of transportation involved in it. So those kind of constraints will make sometimes beneficial use not feasible. And I also do look at this perform sustainability assessment to look at does it make sense to use this material rather than virgin material, natural material. So can we, from environmental point of view, economic point of view, social point of view, we do the sustainability assessment. Does it make sense to use this material? So a lot of people just working in beneficial use of waste materials application, they don't look at this entire picture. They just look at some testing. So this material can be used for field applications. But there are a lot of things that needs to be considered carefully. So again, that from the mine site I mentioned, we got a lot of samples, and there is an evaluation going on at IIT ISM. Can we use this overburden as a substitute for sand and gravel? So there are a lot of applications for these kind of materials: fine aggregate, coarse aggregate for concrete, base course for roadways, backfill material, drainage material. You can imagine fantastic uses of these materials in civil engineering construction. My only concern is processing. Does it need gradation? So where do you do the processing? Do you do on-site or off-site? And then transportation is a big issue. So we need to look at these, constraints, in order to decide on whether it is really practical or not. And the other issue that I found interesting in this mining is environmental pollution problems. There's not much emphasis on this, until recently. I understand now the Ministry of Environment is, trying to impose some environmental controls. So if you go to a mine site, there are a lot of environmental pollution problems you can just observe visually. There is a dust issue, there is an air pollution issue, there is a stormwater issue, there is a wastewater discharge and infiltration issue, there is a leachate coming from overburden or coal or ash, that mixture of all these materials. And then there could be ash and fine sediment transport that could be happening too. So all these things are bad. If you have a lot of this unwanted, pollutants, then you have to be concerned about, workers and nearby community, their health and safety. Nearby land, agricultural land, that could be contaminated, and food chain could be contaminated, surrounding rivers and lakes and groundwater. So you can associate all these environmental pollutants to a lot of impacts, and any exposure to these kind of toxins, most of them could have metals, depending upon the mining is a coal mine or other types of mines, you could have different toxins that could be present, and any of those things could pose health problems to people, and also could adversely affect the environment. So, as I mentioned in the very beginning, environmental remediation is my main field of research, and we can apply the same kind of protocol. Just because there's some contamination does not mean that you have to go there and spend millions of dollars to clean up. So you need to do the proper environmental characterization, and this is a little bit challenging at the mining sites because you're dealing with large sites. And some remote sensing techniques or some other kind of aerial techniques that can pinpoint where the contamination is, that would be a great tool to use. So then you do the risk assessment. I'm not going to go into details of this one. So is it really posing the contamination that you have, is really posing a risk? And then you establish the remedial goals, identify the potential remediation technologies, and we do the preliminary design and do the sustainability assessment. And then we select the sustainable remediation method, and then we apply. So this logical framework is available that can be applied.
Sir, I request you to conclude, sir.
This is the dust problem is a big issue, and there are ways to, instead of using a lot of water, you can use this, biopolymers and some other kind of sustainable techniques that you can use. And regarding the stormwater, there are a lot of, innovative techniques and passive techniques and economic techniques that can be used to clean up the stormwater. These can be applied at the mine sites. There are a lot of different technologies for soil remediation and groundwater remediation. And you can look at, there are bio-based technologies that could be easily applied at mine sites. So if it becomes necessary to address this environmental pollution, we have technologies that can be applied. So the last slide I want to mention is this. Okay, you have a mine site, what do you do at the end? Of course, if you are backfilling it, restoring to whatever the condition that it could be to be, fit into the environment, that's fine. But otherwise, we have been doing a lot of research on phytocaps. That could be one way of doing it. And I was glad to see at one site, one of the, one of the closed sites is converted into park, and nearby people were using it. That's an excellent opportunity to look at it. So just in closing, I want to mention that life cycle sustainability is a very important aspect to look at, in mining. From beginning to the end, in the beginning, as Dr. Rao mentioned, nobody considered about closure plans, and then there's emphasis on closure. Then now more emphasis on post-closure. So in all these things, every life cycle stage, you need to look at triple bottom line, environmental, economic, and social aspects, and not only looking at these big life cycle activities, but whatever the project that you're looking at, even small projects, you want to look at this triple bottom line, look at the sustainability. There are some frameworks that can be applied to assess the sustainability. So I would recommend, in mining, anything that you want to do it, look at through the lens of sustainability. So with that one, I'm sorry, it took a little bit longer time, but in considering the time constraints, I want to end here. And if you have any questions, feel free to email me. And I will be able to answer those questions. Thanks a lot. And Dr. Ramchandra, I want to pass on to you.
Yes.
Thank you. Thank you so much.
Thank you very much, sir. Thank you very much for giving so much in detail. I request the students or participants, you can send an email to sir in the subject with reference to NITK webinar. Sir will respond. Thank you very much for joining us so early morning. And still, I'm trying to learn your systematicness. So much the initial photos you have shown, even I don't have today. I'm not sure where I kept. Still, that systematicness, still I'm trying to learn from you, sir. Thank you so much for joining us. Because of lack of time, we have to move to the next speaker.
No, it's my pleasure.
Professor Debasis Deb is already online. Professor Dev, sir, I think you are there.
Yes, I'm here, sir.
Yes, sir. Yes. Krishna Reddy, sir, you can stop your screen sharing so that Professor Dev, sir, will share his screen. Professor Devashish Dev is presently serving as professor in Department of Mining Engineering, IIT Kharagpur, and is currently also Dean Undergraduate Studies. He graduated in same department in the year 1990 in mining engineering. He did MS from the University of Alabama, Ph.D. from University of Alabama, and after that he worked in US for a brief span. Then he moved to IIT Kharagpur as a faculty member before taking up the charge as dean. I know him very closely. Head of the department. He is instrumental in doing certificates. So his research is a well-known academician in the country with a very strong research background. His works, his projects are worth of crores of rupees in Indian currency. Above all, in one line, if I can say, is the academician, among the few academician, is the one who received National Mineral Award, which is the highest honor in India for a mining engineer. So once you are a recipient of National Mineral Award in India, any award is considered to be little lower than that. So with this brief introduction, already students have Googled the speakers' biodatas in detail and they sent so many emails to me. May I request you to start your presentation, sir?
Okay.
And, you may reduce 5 minutes. You have to give us back from 25 minutes, sir.
Okay.
Yes, sir.
All right. So I hope everybody can see this.
Yes.
First of all, thank you, Professor Ramchandra, to invite me into this webinar, and also our good, friend and mentor also, Professor Rao. He is still here. I am very happy to see him after a long time. Last visited NIT Surathkal. So as I promised, I'm going to talk about a little bit on digitization in mining systems, which I think probably the last industry which will be doing that. And I would say the Professor Rao has made my path of talk very easy because he has already told about many things regarding the digitization and Industry 4.0 and all this. So dear students, if you are listening to me, and you also heard a lot of things about Industry 4.0, and probably you have Googled it and you came to know what is meaning. There are excellent articles on this available, but I have taken a simple definition from Wikipedia, which tells basically the key word is automation. You are shifting from the traditional manufacturing to a very modern and the smart way of making the systems. So machine to machine communication, this is one. And can I hold for a minute because I have to take this call. Hello. আমি একটা মিটিং এ আপনি একটু হ্যান্ডেল করে দেবেন ব্যাপারটাকে হ্যাঁ ওকে 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 ঠিক আছে থ্যাংক ইউ ওকে sorry. So machine to machine communication is one of the key, and what Professor Rao has already told you, IoT. And I'm going to spend little time on that also, because we have also done a little bit of work, but I will not get into that. But this has started in 2011. See, in Germany, and they initially named it as a computerization of industries. So now, if this is the fourth revolution of industry, then what was the first one? It is the hand, steam, and water power. Okay, that is where the industry initially started. Even the mining industry also. You know, even there are some mining works going on which is completely manual. So we are in some places, we are still at the first revolution going on. Now the second revolution is basically the electricity. It started with that. Telegraph, that is the telecommunication we started. And definitely the railroad, which basically carried another big mass movement of communication. So the power of communication, which started with electricity and railroad and all this. Third revolution is basically computer introduction into the industry. Then some digital technologies which may be computer controlled, may not be computer controlled, but some form of digitization has started. Now the fourth revolution, mostly people have thought it will be the bio-revolution. And I think in between this IoT and machine-to-machine communication and all these things have come, but I would say bio is not far off. And this COVID situation has made it even faster. Now people realize the power of a virus or a bacteria, and which can stop the entire world. So the bio-revolution, along with this Internet of Things and the digitization, will be the fourth and fifth revolutions of industry revolutions. So this is where we are heading. Now, this is just a graphical representation, and I would say most of my graphical representation has been taken from the internet. So you do not have to take pictures. These are readily available. And we have carefully checked that we can show this thing to you. So as I told, the first one is the manual. So you can see that. Sorry. And so first one is this manual. Second is this communication. It should have been rail and electricity and all this. Third is this starting of robotics and computerization. And fourth is what is totally machine to machine talking. Okay. And this is where again another good pictures we got, even giving the year how this revolution has started. So right now we are approaching there. Okay. From this third to fourth, we are approaching. Now, the question is, if we are approaching there, is mining industry ready? So, do we have a mining 4.0 yet? So the question is, this may not be yet there in the entire world. If a very few cases, few examples are there. Other than that, in a mass movement, has not started yet. So this was the manual. We are getting whatever the mineral from this thing due to manual. Then it came to electrification or by gasoline. then the mechanical system with either electrical shovel or diesel operated shovel, and then the power of longwall. Okay, but does this longwall can be controlled automatically from the surface? A few mines have shown, like one of this is the Kiruna mine, where the machines are controlled remotely. But as I told, that it is not everywhere, so it has not come yet. So mining 4.0, we are getting there, and I'm going to give little bit of thought that how we should go there and what will be the future of our mining industry as well as education. Remember that mining industry is very traditional, very labor intensive, and needless to say, very conservative to change. So, having said all these things, moving from one revolution to another definitely takes time. Now, do we need the change? Okay, this is the main question one should ask. So, there was an excellent, report has been created, the mines of the future for 2030 and beyond. This is by the Society of Mining Professors. In 2019, they have published this, and the 4 point has been taken from this report. And what their first concern is whether we will be endangered species. So, like one of us will be in the museum and they will say, hey, look at this guy. He was a mining engineer, probably 20 years ago. Okay. So, are we becoming an endangered species? That means no longer needed. Okay. Because all mines will be automated anyway. So, do we need a mining engineer? Will the industry rely on only mechanical and mechatronics or IT engineers? Okay, that is the next question they have asked. Then the question is, if this is the direction, if the industry is going to go, then what should be the mining engineering curriculum? Okay, what we should teach to our students who are, as Professor Rao says, very much tech-savvy. Okay? Now, how much traditional mining knowledge they need and how much knowledge they need for the future to sustain, to develop, that balancing whether we have already started doing. And so, can this other discipline run the mining of the future? This is a big question mark. So, these all four are, you can see the interrelated questions, and the mining engineers and the mining educator, mining industry has to pay a, very deep look into this, that where we are heading in mining 4.0 era. This is taken from Geovia. If you search there, you will see this. This is an excellent graphic or the cartoon for future mining. This says all what is going to come. See, if you are in your final year or in your third year, or if you are a M.Tech students, you know ore body modeling, right? And we do geostatistics to find out the grade of our different blocks. So now this grade is known here. Now once it's blasted, we know which area is blasted. So when a shovel is, picking those blocks into a mine truck, we already know what is the grade, average grade going to this truck. Now this truck is coming to surface and it is dumping to the crusher. And if you have a sensor in this crusher, So we will be knowing what will be the grade coming out of this crusher. And then after the processing, we will know how much grade is coming. So all these things are totally automated. So right from the mine side, right from the mine side to the crushing side, okay, and when it is coming out of the processing, we know that certain percent of grade was there and how much percent is coming out. So whether we need a calibration, whether we are grinding it well, if we are not grinding it well, then do we have to grind again? So all these things can be fully automated. Now, does it mean a mining engineer is not needed? You ask yourself. I think very much needed. And they need more knowledge than what we are imparting you at this point of time. So you have to be smart enough to even design a system like this. Okay? Then if you go towards the underground, the similar thing will happen. So the underground is much more complex. We have so many equipments which are moving equipments, conveyor belts, then LPDTs, then if you are using LSDs. So all these things, and if you are going to the coal side, it's a continuous miner systems. Then your long-run mining systems, the support, everything can be sensor based. And those sensors should tell you the health of that mine, that center should tell you the production, the center should tell you what is the health of that machine, and those can be automatically, and that data can come to the surface, you process it and send the signal or send the feedback. Now this system, my friends, are coming, whether we do it or somebody else do it. Somebody else meaning the mechanical or IT people do it. This is going to come. Now whether we seize the opportunity, the mining engineers, and they say we can also do it, that is the question to be asked at this point of time. Similarly, I already told you about the underground system. Now, we have done in one mine here in Eastern India. We have used the IoT systems to collect the data from the supports, from underground all the way to the surface, and it was continuously monitored, and we have analyzed the data and all these things. But the power of pump, that is what we are saying. What is that? A small piece of equipment you have, everybody, do not ignore it. Try to use it. It's just not for WhatsApp. Okay? It can do much more than WhatsApp. Okay? That is what you have to pay attention to this. You have to know the power of the pump, power of the equipment you have in your hand. Okay? And how to use it properly for the benefit of the industry. One such, there are a few examples which has been done in Australia and in Canada also, and even in Sweden. So this is a mine of Rio Tinto. You can search this in Pilbara, Australia. And the mine is here. And this is the path, completely manless dump trucks drives the material to all the way here. So it is completely manless, okay, or the driverless truck. Totally controlled by your Internet of Things, your satellite, and all these new devices. Okay, so 1200 kilometers away from path, completely remote control operation is going on. So already a few cases, this has been shown a successful operation. Even in Argentina, there is an underground mine, underground copper mine, where this kind of system is being used. Now, this slide is little faint, maybe you are not probably seeing, but I've listed a few mines name. One of them is in India. That's why I have round this. So, in a Hindustan Zinc, SK mine, in a SK mine, they have implemented a Sandvik Optimine digital platform. And this is in underground, just like a truck dispatching system type of thing, but it is in the underground. So some technology has come here, but we need more of these technologies in the near future, or the very 5 or 10 years time. This I found from many different, because you see, any new technology, those are great. One satisfaction is whether we are able to bringing the technology to the market. Another is whether market will accept that. Okay. So, everything, my friend, ultimately come down to economics. So I had basically searched whether anybody has forecasted that this kind of technology, how much, marketability of these technologies. And I found everywhere they're saying even more than double. This is in 1927 they are projecting. This is even in Mexico they are projecting. So in everywhere they are projecting that if this technology come, this will increase the productivity as well as increase the profitability. So means it makes all the sense to go into this technology or invest into these technologies by the companies. Okay. Now I come to the academia and research, which some of you may want to pursue, and some of us like to, get into this field also. So there are a few universities where some subjects I just want to name, like this is a subject is being taught in mining engineering. This is being taught in mining engineering program. So the University of Queensland, they are teaching a subject called control system implementation to mining engineering students. In Canada, Queen's University, they are teaching mining system, automation and robotics. Okay. So this is a core subject for them. Computer application and instrumentation and mining, this also we teach in our country. So they are also doing that. In University of British Columbia, there is a title of the subject, mining in the future. Okay, that's very interesting. Title of the subject, they have already started that. And mine automation, I think this is a very common name. We also do, in the name of that, we teach many things. But these are some of the topics which they do. Like ventilation on demand. This is one of the thing is very popular. In geomechanics, in instrumentation side, you can do a lot of things using IoT. So these are the few universities or the departments, mining engineering departments, which have started one or two subjects. So I would say we are way lagging behind. If you are talking about mining 4.0, I would say academia is not ready yet. So we are not thinking in that direction yet. So we need to think, even I'm talking about globally. It is not any local phenomena. So what are the future for research area? So definitely the IoT and digital mining systems. And by the way, in December, we are going to conduct a similar webinar on Smart 2020. So we have given the name is safe mining and technology resources. So it's a smart 2020 we are calling it. So we thought initially it will be offline conference, but because of the COVID we need to change it. So this will come very soon, the notification. So the IoT and digital mining and artificial intelligence, those are already there in the market. So even a few research topics has already been framed in our department, and it is being going on. Sensor-based instrumentation in geomechanics and mineral sorting is the way to go. I think that a lot of things can be done in instrumentation side. Smart and remote control machines, definitely this is already started by many companies like Sandvik. Then here in India, BEML is started doing little bit, but I think they are not as close as Sandvik. There is a Robert Bosch. They are making a lot of smart sensor for mining applications. Drone. This I think we should be doing 3-4 research on drone. How best we can use. Right now, everybody is talking about surveying only. What is this? We can get it done like environmental control using drone. Why only camera we put there? We can put lot of different sensors and see what is happening even 500 meter above a open pit mine. Friends, you will hardly see within 4 to 5 years time that drilling blasting will be the thing of past. It has to be. Okay, we have to go into a continuous method of mining, and this is the way of the future. So, how best we can replace drilling and blasting with machine? This can be a wide range of research can be done. So there are rock, the strength, hardness varies widely. So whether the continuous method of mining is possible in every possible cases, and then the mining method will change completely. So the method of mining with a continuous machine, if we just think of that point of view, you see the use of mining engineers and his knowledge that comes here. So no way we are going to become an endangered species. Even we have to come very strong, and we say, hey, we have to get into a new mode of mining methods. And other than that, mineral characterization, so full space scanning, remote hyperspectral, virtual reality for safety and training, those are already being used in other field. So mining field also there are applications being going on. However, there will be challenges in IoT when we go underground. We have already faced that. The signal issues, how to bring the data, that big data from underground to the surface without the loss of data. So those are very important. So that challenges, as we go along, we will know those challenges and we have to overcome them. That's it. Now, let me, since I'm talking to students, so I thought I'll give this part of the lecture also. This I presented to DGMS and they have appreciated it, and some of our PhD student is thinking of now going into this mode. You see, our government is giving lot of thrust in startups these days, and they are saying Atmanirbhar, the Make in India push. And in that case, we must be, here is the example with IITs, and that can be replaced by any university. Right now, we directly talk with them, okay, the IIT to industry. So we are solving many of their problems. But I think there is a good possibility that startups can come here in between. And if you are linking with us, okay, so you instantly get the support, the software support, the hardware support, the testing support, all these things you already get from us, from the universities like us. And then you can directly talk with them, keeping us in the background. And if this model is acceptable by this DGMS people, I think we have a fantastic model, okay? And this way, we can develop our indigenous knowledge. We can collect a lot of data, and those data can be analyzed by these young people. And why only IoT? You know, we can go into n number of cases where starting from mining methods to smart machines, everything can be built in this country. So this is how we shake hand with the, this is a true industry academia collaboration through startups. Okay. So far we only talk industry academia collaboration, but never happens. So if you want to do it, I think there must be somebody in between, and those are our students who will be graduating or who have already graduated. If they can form a startups, and they can gradually become the experts in geomechanics, in safety, in you name, in environment, in everything, and gradually you will become like a consulting firm, big consulting firm like SRK. So we can build our own indigenous consulting firms, and then you not only do business in India, you can go outside also. But you start with here, develop your skills through this interaction, and if the blessing of DGMS and all these people comes, I think this is a very successful model. So this is the synergy I have already told you. Now it has a lot of strength and weaknesses. I have presented them, so I'm not going to bore you with that. There's a SWOT analysis done. So my final recommendation is that the mining academics, we are not there yet for mining 4.0. So,
sir, may I request you to try to conclude, sir?
Yeah, this is my last slide.
Yes, sir.
Okay. So the experience of digital technology, we are lacking, what Professor Rao also told. So we have to quickly get, people who are expert and get them into our board, into our department, and train them into the mine and tell them, see, you have an ocean of opportunity in mines, and use your technology with us. So this data analytics, advanced modeling, statistical tools, those are already we know. And finally, what I like to sum up is the startups. It has to come in our country, especially in the mining field, to become a global leader in mining. And since this now 100% FDI is also allowed in the coal sector, I'm hoping many of such startup will come and will grow our industry, and will also give a lot of impetus to our academic system. Thank you very much.
Thank you very much, sir. You have given a lot of inputs especially for students. Startup is a crazy word for them. Parallelly, I am following up so many questions on YouTube. Many are asking which university is better for this. Already have mentioned few points, and The foreign speakers are soon joining us. In fact, they are there on the on live. You will get one question. I got attention of particular student. He says with a little frustration, industry is not giving internship, academic institutes are not taking care of the students. So much big message. This is one of the initiation that we are taking care of the students. And if any internship you want at M.Tech Surathkal, please contact the HOD or the faculty. We will provide summer internship once the COVID situation will become normal. Not all, whatever, wherever possible. Thank you very much, sir. Now I request the next speaker, Dr. Neelima Satyam. Hope you are there, ma'am, online.
Yeah, I'm there.
Dev, sir, can you stop sharing your screen? Dr. Neelima Satyam is a very young and dynamic leader in academics. At a very young age, she is heading the Department of Civil Engineering at IIT Indore. I am not going into full biodata of her. She was earlier with IIIT Hyderabad, and she did her master's and Ph.D. both in rock mechanics and geotechnical engineering from prestigious IIT Delhi. You name any award in the area of geotechnical engineering, she has received like DST Young Teacher Award, IE India Young Engineer Award, BRNS Young Scientist Award, Young Woman Engineer Award. When I spoke to her, she wanted specially to focus on challenges and opportunities for girl students in engineering. I am fully aware that there is an international wing called Women in Engineering. Some of the programs I have seen in US, they are very active. Though a lot of efforts are being made by government or other organizations, still enrollment of women in engineering is still poor in India. We thought this is the right point to speak on this webinar. Ma'am, it is over to you, Dr. Neelima Satyam.
Thank you so much, sir. My screen is visible. Okay.
Yes.
So good evening, everyone. First of all, I thank Professor Ramchandran for giving me this opportunity. So when he called me, I picked up this particular topic because I would like to share the experience as a civil engineer and or more as a geotechnical engineer, which I've been seeing in the last 10 years of my academic experience and several years of my student as well. And let me tell you, it's not like challenges and opportunities. I put it as opportunities and challenges to be positive in the starting and then show what we can do. And I tried my best. It's not for only girl students, so that's why I put it in the bracket. It can be for everyone. I'm not a gender bias. Please don't take me wrong. And the second thing is like it's not even for geotechnical engineering or civil engineering. Me being from geotechnical engineering, so I would like to give you some statistics related to this particular core engineering, like mining engineering as well. But it is almost same for other core engineering disciplines like mining, mechanical, or like electrical also. Like where we see very less girl students, even in IIT or any other institutions, we see very less number of girl students enrolling into civil or mechanical or mining. So which is like really not good, because it's not it's a kind of myth, I feel, because I used to interact with some of the parents, and as a Vignan Jyoti scheme coordinator from IIT Indore, I used to talk to several girls and the schools at school level, +2 or +1, +2 students, and also to the parents. Not only that, to some of the coaching centers as well in the last 1.5 years. So when I looked at this particular thing, I felt like there is a lot of myth in the society in a large, where we need to address it. And just want to show you some of the good part, or like the actual part, I can say. Whenever first of all, I know that the webinars every time we got a chance to talk more of technical part, but I took an opportunity to speak about the core problem which I personally see it. So here I'm just putting it up more of a infrastructure industry. It's just not for the civil industry. If you see here, even in this COVID situation also, the government is spending huge amount of money on infrastructure, like for construction of roads or for sustainable development of the country. If I look back at some of the statistics, in the world's third largest construction market in 2022. And if I look at the sustainable development, Professor Krishna Reddy has given, like I'm also working with him as my collaborator. sector, where we are also working together for sustainable aspects of slope stability. I have seen one of his slides where bioremedial or MICP techniques, where like one of my PhD students is working at present. So how to stabilize the mine slopes. So let me tell you, it's not about mining engineering or civil engineering or any other engineering. It's all of a like a holistic. When you really want to solve a problem, so it cannot be a particular step. It's actually engineering. So let me talk about the sustainable development of the country. Whatever I have written at this particular slide, huge amount of money has been going to be invested in the country, public money, and sustainability also includes like how to use the mine waste, okay, for our construction and etc. So it is all of integrated approach or a solution that we all should work together and come up. In 2020 April, the government also targeted to construct huge amount of roads. Let me tell you, we have extensive problematic soils in the like Madhya Pradesh, Maharashtra, UP, coastal Andhra, several states. Like we do have expensive soils. It's need to be treated, right? It need to be better. I'm just referring to one of these slides where sand and gravel requirement in 2060. It's a huge for construction industry. How to replace it with any mine waste or any power plant coal waste or like fly ash or whatever, bottom ash, how to use that. There is a huge amount of research is required because people are using in a piece way, but we don't have a holistic approach for that. And second thing is like energy sector, it's expected to invest huge amount of opportunities, like with millions of dollars in the next 10 years is going to come up. And NHAI is also able to generate huge amount of revenue through its toll and bayside amenities in the next 5 years. So this is actually the statistics. I just took it up. Similar to that, construction sector for transmission towers or complete communication system, telecommunications, so a huge amount of budget has been allotted by the union government. So don't consider this as a career opportunities for civil engineers. I know that when I was doing my masters, we used to have mining students also who used to do B.Tech in mining students used to do M.Tech in rock mechanics. So there is like some percentage of seats have been allotted for mining students for doing it. So it's not about only civil or infrastructure engineering. It's more about engineering. That's what I want to say. So several Professor Dev was also telling there's academia has to be. It's not with only mining. My personal view is like it's even for civil engineering also, where we are not exactly ready to the industry because industry needs they run with the time, so they don't have time and they want a skill. But what we teach in the campus is like we teach them knowledge, right? We teach them fundamentals. So but at the end of the day they have to apply their skill, right? They need to be trained for the skill. So that is a gap which I personally see it. But let me tell you, huge amount of opportunities are there in the infrastructure industry. I don't want to go in these slides, but I'm happy to share some of the slides if possible. So, but large projects with a lot of global partnerships, they're offering huge amount of challenges and a lot of exciting opportunities. And let me tell you, there was a question which I just saw in the chat box when I was listening to other speakers. So Pooja wrote something like, what is the role of geophysical engineering versus in mining engineering? There is a huge amount. I just want to answer that particular question and go to the next slide. So geophysical engineering, where we can characterize the site, okay, large area, what is there below the ground, it can be GPR, it can be, or ERT, whatever geophysical test you do it, you can characterize the material. So that is possible, that is the application of geophysical thing. Not only that, even for monitoring also, we use a lot of geophysics in monitoring, some of these slopes or some mine structures. So coming back to this, where we are not only applying particular knowledge of this particular thing. So though my slides are saying only civil engineering because I'm confident to say this, but other substreams also they are the same thing with mining engineering or in mining sector as well. So not only that, we are having a diverse range of career opportunities in the infrastructure industry in large, like even for you also project management, of course, design and engineering, where you will be designing the mine slopes or any kind of transport of mine material, etc. Planning, supply chain, contracts and client management, commercial and project finance, business development, estimation and tendering. If I look at some of the students, they're very much attracted for their first job, right? Like it can be in IT sector, like where they need people in mass. But let me tell you, because most of the students are over here in this webinar, please prepare yourself for the last job, not for the first job, because if you are in your core area, and there are so many opportunities. The only thing is like you have to explore it and take the guidance of your teachers or who are mentors, and then look around. So there are huge things that can be done. If you see here itself, I just listed the 8 different career opportunities that you can go into it, and based upon your interest. So sector is not glamorous like your sector or our sector, civil engineering or mining engineering, mechanical engineering. It's not so glamorous as we do see in the IT sector or any other sector, because we're not working in the urban setup, right? We do our projects are at some remote areas and they're executed at interior parts of the country, and these locations doesn't have very good socio-cultural context and lifestyle expectations. So these are some of the things which we can see as a challenge, and so many they don't prefer hardships associated and move to other sectors, and also this is pursued as a largely unorganized in its approach with a huge high degree of corruption and political interference. So maybe not entirely true. I don't want to consider that, but unrealistic expectations of the students is far remote from reality, leading to early disappointment. So this is, I think, which you have to look at in a longer perspective, the next 20-25 years, where I should be, what I should do, and how the industry. So I really appreciate this particular webinar where students they'll be given an opportunity to hear to the people, general technical thing. You already know it from your teachers, textbooks, and NPTEL, whatever. There are different sources, multiple sources these days for technical part, but to understanding the opportunities by calling people from all around from different sectors is something which I really appreciate about this webinar. And the biggest challenge is to attract high quality students for their long-term career in construction industry. Let me tell you, same as you, civil engineering students also doesn't have, the first job is not that attractive. So, but think about it, your last job will be very, very good, and you should prepare for it. So what is the main objective? Many people were asking about the internships also. The same thing, we also face it. To attract high quality students to the construction industry, there is some program which I am part of it now for internship at the country level for building Bharat. Okay, so this is actually a very big program which is coming up, and where we would like to link with the industry. There is an industry partner along with me as a leading partner. So we have some HR people from the industry who are taking some road shows and going to the campuses, or going to the what to call industry, and we are trying to fix it up something like this. Like after second year, after third year, after fourth year, is not giving an internship in chota mota projects, nation building projects, where they will be given some paid internships of at least minimum 10,000 with accommodation and something like that. The similar sort of model can be worked out for mining people also, or together we can build it up along with mining and civil, because there is a lot of things, related things that we can work together, and also to offer a realistic orientation and overview of the sector. So these were some of the objectives which we were preparing and working towards it for the construction industry in large, and where practical experience can be gained for the students, and we are ready and prepared with the realistic expectations. So let me go back to this particular part, and this is what my core area of geotechnical engineering, where I do work on soils, I do work on behavior of soils, understanding under different environmental loads, under earthquakes, and different kinds of hazards. And this is my area, and let me take some look into it. I start this because my topic is of more of girl students, or women in civil engineering or geotechnical engineering in a more specific. So soil, maybe for mining students it may be little new, but soil we consider is very porous, and this is a material which we work with, and it's a civil engineering material, and it's the only natural material with which we work, and complete load of whatever it is, it is completely going and taken care by the soil. So it is porous material, it is highly particulate material, highly heterogeneous, non-linear, isotropic, and it's all pressure dependent, strain rate dependent, temperature dependent, and undergo a lot of volume change in shear. But yet the material is very interesting, colorful, sensitive, and possess memory, because we do talk about a lot of consolidation things, and there we know that over consolidation issues and all, we can say that soil has memory, and it changes its properties with time. So it is a complex material which we deal with. So with that, I just want to shift from my talk from what are the challenges for the girls and why we have less number of girls, and with a kind of myth in the society. So though we are 50% in the society in terms of population or whatever it is, and girls do extremely well till their +2, but very few students join the technical programs. So to understand and trust this is a society problem as in a larger way, and we need a proper representation from every section which can bring a specific experience and also the perspectives. So diversity of views and ideas strengthen us academically and intellectually. So it is very, very important for all of us to have this. This is the current reality. In my class, when I was doing my masters in Delhi, so I was the only girl in the class. So anyway, who influences the career choice? So it's like not just one sector or one thing. It starts from the school. I've been looking at it very critically in the recent past. I'll just can share you some of the examples. I have girl students who are doing PhD with me present or in the past also. They did extremely well. They were very strong physically also. They used to go to the field. I did huge amount of field testing for my part of my PhD, and my students too are going to their neither. I mean, you cannot say that they cannot do or they can do. We cannot do that. Okay, they are doing extremely well. So, and when I was talking to somebody in a quota from a coaching center, the coaching center itself is telling girl students, this was 2 years back, don't prefer this engineering, that engineering. So engineering is engineering all today now. So we do have a problems which are highly multidisciplinary. If you really want to solve a problem, it is multidisciplinary. Okay, in civil engineering, our students are working on AIML now for landslide hazard monitoring, modeling aspects. So it's not like only particular area where you are just going to the field and doing this. So, and we are making up to 42% level, students in STEM subjects, but in the workforce or in the education universities also we are very, very less. And let me tell you, in my department at present, in civil engineering department, I was the only woman, and so we are very less in terms of workforce and also in the industry. 8% of all professors are females. And just want to take you to some statistics, and at colleges and universities also, we can tell, like last year when I was doing my duty as a JEE chairman of IIT Indore, so parent visited and he was telling to me, because I was in that verification office. So madam, he don't know me, and he was started telling she got civil engineering, and I don't want her, or she don't like civil engineering because it is not for girls. So what should I say? I said, I'm a professor in civil engineering and department head also, so don't worry about it, we'll take. So this is a kind of mental or mindset that we have in the society, which is at the root level need to be taken care. So the barriers are like we have very few men who can be considered as a role model. So we need more, and we need publicity amid like women. And though government is doing so much of support right now, we have even for IIT. JEE also we do have some support for the girl students, at least like 20%, and in addition to that we do have some other programs of research or like funding, or even at different levels they do are given a lot of opportunities in the recent past. So maybe lack of confidence, low expectations of others, or encouragement from the family. I feel myself very privileged because I got the family support, or isolation or lack of support at workplace. So we have to properly inform them this is not the field of only boys or like men. So we are equally capable, because there is other opportunities where we can do much better. The first year of the college in major in science and engineering fields, if you see here, this I have taken from the this particular reference. If you see here, this is the percentage of women or the girls in different areas. If you see here, biological or agriculture sciences, we do have almost 10, and the remaining engineering, maths, and physical sciences, we have very less percentage. Similarly, the achievements and the interest in civil engineering are shaped by the environment around them. So same as that mining engineering. So because I have this numbers for civil engineering, so I just put my slides for that. So even in the master level also, we have very less number of students who are enrolling. And traditional general roles was one of the reason, like where we have availability of coaching centers, tutorial facilities, and safety issues. Parents are worried to send them away from the city for coaching or something. So there are so many problems at different levels in the thing. If you look at the technical societies also, like we do have American Society of Civil Engineering, maybe same for mechanical and other mining engineers also maybe there. So we also have very few representation of women in the society, in technical societies, I mean. So we need more women. in this core engineering areas of civil, mechanical, mining areas, especially to address skill shortages and to avoid waste talent and adverse workforce leads to greater innovations and a better working environment. So my few more points on this is like encourage women for pursue engineering, actively recruit more students and hire more faculty and emphasize the real world applications of engineering. I mean to say that geotechnical engineering is very judgment based, and I feel that there is a lot of things that creative solutions and more judgment solutions can be made by the girl students or women in this particular stream of engineering. So I just quickly made my view, and if you have any queries or any kind of thing, so I'll be very happy to take them. I hope I'm on time.
Yeah, very much. Thank you very much.
Thank you so much
for your presentation. In fact, for your information, the girl students are not eligible to take admission. The Department of Mining Engineering and ITK is the first to offer mining admission for girls in the year 2002 in a government sector. And one of our students has cleared the first class mines manager certificate, first female in the country, working as assistant general manager in Karnataka government. So we encourage a lot. Along with us, the Singareni Collieries Company Limited in Telangana state give special take care of the girl students, especially with our personal contacts. We have been encouraging girl students to a great extent, ma'am. Thanks for your point.
Thank you so much. Thanks for informing that. Happy to hear.
Thanks a lot, ma'am.
Sure.
Because of lack of because of time issue, I will move to the next speaker. Dr. Ritesh Mishra, are you there?
Yeah, I am here. Can you hear me?
Yes. Yeah, I welcome Dr. Ritesh Mishra. He is our own alumni, prestigious alumni. I say a proud product of this department, graduated in mining engineering. In fact, I taught him many subjects. Very sincere and meritorious student who came from basically a bureaucrat's family, but chose mining and continued to choose mining. When I wanted a speaker from Europe, though he is working in Zambia, he got 2 master's degrees from Europe and a PhD degree. MSc in Mineral Resources and Management from Cambon School of Mines, University of Exeter, UK. MSc and a PhD from Aalto University, Finland. I may be pronouncing right, I'm not sure, because European, some names, spelling is different, pronunciation is different. And I strongly feel that we, being Indian students, many of us have not fully explored the European universities, because mainly we are focusing on US, Canada, Australia. So I wanted a speaker from this background, and he is the only speaker from industry background. Though he is working for industry, he has a lot of academic exposure. So without going much into his details, I request Dr. Mishra, you make your presentation. So as our own student, I request to please limit to 15 minutes. Yes, please.
Thank you for that wonderful introduction. Good evening, everyone. Good morning, depending on what time zone you're from. I hope you can see my slides and I'm able to share them. Okay, I'll jump right into it. As Sir already mentioned, that when we think of mining, Europe generally doesn't, firstly for mining, it does not come as the first continent in mind. And when we talk about higher education, it's the last continent you think of. So as an introductory slide, I just wanted to clear that actually there are a lot of mining industry giants that originate from Europe. And in the mining industry, we deal with them, but we never give them the credit. And I've just listed some: Atlas Copco from Sweden, Sandvik from Sweden, Finland, Volvo from Sweden, ABB, Normet, AkzoNobel, Yara. These are all big companies that support mining industry and are all in Europe. So that's why if you come to Europe, there is a lot of places you can visit and learn from. Then the other aspect of studying in Europe is Europe has a very strong foundation in rock mechanics. I mean, in a way, if we talk about rock classification, Q system is one of the most known classification system. And Nick Barton, who came up with it, himself is Norwegian. So that's why that's another sales pitch for Europe, I guess. I mean, if you come, there are a lot of study areas that you can follow. I've just listed some which are quite common and commonly pursued in Europe. So rock and soil mechanics being very popular. Then load and haul optimization. If you go to Germany, there's a very strong research group that studies that, and that's one area that the industry is lacking currently. Health, safety, and risk management. So Finland is very popular for that kind of research. My own doctorate was in the subject. Then blasting optimization. Again, you go to Sweden, Norway, Finland, they're very, very big in researching blast optimization. Then measure while drilling. This is part of the whole big data push where we are able to generate rock mass characteristics as we are drilling from the drill sensors. And there is a lot of work, again, in Scandinavian countries done on this very subject. Tunneling, underground support, automation in underground mining. If you follow Sandvik's own website, they produce a lot of automated LHDs for underground mining, and they have their test lab in Finland. So if you're lucky enough to actually come to Finland, you can visit their automation factory and see how these machines are made. Of course, going to Europe is not only about all work and no play. You come there to study, but one of the other benefits of coming there is you get a diversified employment opportunity. And the reason I mentioned that is among all the countries that are currently pushing for renewable energy, and if you look at the signatories in the Paris Climate Accord, Europe is really, a lot of European countries are part of that. So they're really pushing for sustainable mining, renewable energy. So that's why you get a lot of unconventional job offers there as well. And then given Europe is made up of so many small countries, if you go to a European university, there's a good chance that you will study in a very diverse multicultural environment. And then you have the ability to visit different mining operations. The reason I say extreme environments is because if you travel to Scandinavia, if you go to Finland, there are mines above the Arctic Circle. So you have to learn how to mine in minus 40 degrees Celsius. I mean, that's the temperature where even lubricants in trucks freezes. So, that's another side of mining you generally won't get to see in conventional mining countries. And lastly, I mean, Europe's really popular for travel. So as a student, when you go in your free time, you have a lot of traveling and a lot of extracurricular activities you can do. I've scraped through the internet and basically picked my top picks for higher education in Europe. Of the 7 universities I've listed here, 6 I've had the pleasure of attending in some capacity. So this is not just scraping information from website. I'll give some personal perspective. And they are not ranked in any order. They are just random serialization. So I'll start with Imperial College London. So it's located in London, as the name suggests. And one of the advantages of studying in London is, even though London doesn't have any mines themselves, a lot of headquarters and financial headquarters are in London. So if you study in London and you want to do an internship, there is a good chance that you will get financial exposure in the mining industry. So as part of that, there is a master's course offered by Imperial College London in metals and energy finance. And it's quite a unique course which combines engineering and management. So as I mentioned, London is a good place to get exposure to finance, and then master's course offers that exposure as part of the study. So if you do go to Imperial College London and take this course, it's a very diverse study experience you will have. If you're a student from India or any other English-speaking country, studying in London is very easy. Everyone speaks English. However, London is known to be very expensive. So that is one of the downsides of going to London. And lastly, easy access to headquarters, but not so much easy access to any of the operating mines. So you'll have to travel quite a bit to actually go and see a pit. Moving on, the next one is Wrocław University of Science and Technology. This is in Poland. Poland is one of the few European countries that is still pushing for conventional mining and fighting tooth and nail to retain their conventional coal mines and copper mines. So that is why studying in Poland actually gives you exposure to some really large open pit operations. I mentioned one of them. KGHM is one of the large-scale copper mining companies in the world. They're the 10th largest currently. So if you do go to Poland, you have a good chance you'll get to see one of their pits. They offer a master's in mining and geology, and you can specialize in one of the 4 options I've mentioned. There will be a copy of slides. You can go through them. And for the sake of time, I'll push on. Poland's also excellent for doing doctoral research, and currently they focus a lot of their effort in rock mechanics and mining operations management. Rock mechanics, because mining is getting deeper and deeper in Europe. The deepest mine currently is about 3 kilometers deep. And operations management, because of the focus on cost saving and efficiencies improvement. And one of the advantages of going to Poland is in Europe, Poland is one of the relatively cheaper countries to live in. So, it will not be a big impact on your pocket relatively. However, the one downside is that in Poland, people predominantly speak Polish. So you will have to face some language barrier. In cities, you can get by speaking English, but just be prepared that when you're asking for directions, someone won't understand you. Moving on, Luleå University of Technology is based in the northern part of Sweden. As we speak, it is the northernmost university of technology in the world. So it's literally, you will be at the edge of the world if you go to this university. It's a really beautiful campus and lots of opportunities for research. Currently, they offer a master's program in civil engineering with specialization in mining and geotechnical engineering. And Sweden is also big in mine automation. So if you do go here, you have the option to get first-hand experience in mine automation, operation and maintenance engineering, dam design, mine economics, and applied rock mechanics. Some of the famous rock mechanics books are written by authors. I mean, Nick Barton himself comes and teaches at Luleå. So you will find, your role models of rock mechanics likely teach here. And as I mentioned, they have a strong research background in rock mechanics. One of the advantages of going to Luleå is close to a mine called Kiruna. Kiruna is one of the only large-scale underground mining operations of that scale in the world. And it's funded partially by the government and partially privately. Because it has government funding, they facilitate a lot of rock mechanics research. So there is a lot of underground rock bolts types that have actually come from this mine. There is one type of rock bolt which is called the Kiruna bolt, which actually originated from this mine. Sweden also is home to the mining company Boliden. They own a lot of mines across the world. So if you go to Sweden, you can visit their mines as well. One disadvantage of Sweden, however, is that being based in Scandinavia, it has a high cost of living. So living is very expensive. You also have a moderate language barrier. People predominantly speak Swedish, but you often find that you can get by if you speak English. One early warning, if you do go to Sweden, temperatures can drop to, in the university itself, it can drop to -20, -30 degrees Celsius. So if you don't like winter, I wouldn't advise going to Sweden. Moving on, University of Exeter. So University of Exeter currently offers mining through their satellite campus called Camborne School of Mines. Camborne School of Mines is about 160, 170 years old university. And they offer a master's program in mining engineering, geology, environmental management, tunnel engineering. The university was established to cater for the mining industry that was in UK back in the days. But as we know that we are slowly, there are very few quarries and mines left in UK in the push for sustainable and renewable energy. But there are some lead and tin mining coming back to UK. So that's why, the university is still going strong. There is research focus on mineral recovery, geotechnical and safety engineering. The one personal comment that I will make about University of Exeter, because I've been to the university, I feel that University of Exeter and Camborne School of Mines currently produces the most employable mining engineers. So it has a very strong alumni network. So if you are going for higher education purely to get a job, it's a really good place to go and study, because you will interact with a lot of alumni and very good chances of securing a good job. Moving on to Germany. So Germany has the University Aachen. Aachen is located at the German and Dutch border. Again, I had the pleasure of studying there for one semester. Very beautiful campus. And as some of the people mentioned in the YouTube comments, there is no tuition fees if you go study in Germany. But the caveat is that you have to learn, I don't remember what exact level it is, but some level of German proficiency. So even if the language is taught in English, you have to know some level of German if you go study there. But if you do manage to master that and you want to do a master's, you can do one in mineral resource engineering, which covers process technology, extraction of raw materials and energy resources. I mentioned in the beginning that Aachen is really good if you want to study load and haul optimization, or you want to do any research on operations management and systems engineering. The university is also close to some of the largest coal mines that use bucket wheel excavators in the world. So if you do go to Germany, a very good chance that you'll get to see this mine. And if you don't go early enough, Germany is planning on phasing all their coal mines by 2040. So if you do want to see some impressive bucket wheel excavators in action, 2040 is the last year by when you have to see it. And of course, German energy policy is pushing for renewable resources. So if you do go to Germany, you can study unconventional energy resources and diversify your portfolio. As I mentioned, it is preferred that you know German language. But the one good thing about Germany is that the cost of living is relatively low. It's actually, nearly close to Poland. It's fairly low for students. Moving on to Netherlands. Netherlands, TU Delft is located in the coastal city of Delft. It's not far from the city of Amsterdam. It is close to the Rotterdam port and the sea underwater mining company IHC. They do dredging as well. The reason I mentioned Rotterdam port is a lot of mines, the minerals that are produced in Europe have to come to the Rotterdam port go to their external clients. So if you do go to Netherlands and you do happen to go to Rotterdam, you can actually learn the logistics side of mining. So after the mineral is produced, what happens next? The life cycle of converting a coarse ore into a finished product. So that's a good place if you want to study that. They do offer
to complete this.
Yeah. Then you can do Masters of Science in Geoengineering, research area in rock mechanics, dredging, deep sea mining. Quickly to Aalto University, which is in Finland. Again, strong in risk management, soil mechanics. There are a lot of mines in Finland that people haven't heard of. Large-scale copper, nickel, gold, and chromium mines. Finland is also the unique place where you can actually go see an underground nuclear waste disposal facility, which is state-of-the-art, and you can study it, you can do research in it, in the rock mechanics aspect of it. The one unique thing about Finland is despite being in Scandinavia, it is highly subsidized for students, so very low cost of living. And apologies for the typo, English is widely spoken in Helsinki, so if you do go to Finland, there is no language barrier. My last slide, and my preferred slide. So there is a unique amalgamation of course called European Mining Course, which 3 universities offer jointly, namely TU Delft, Aalto University, and Aachen. And if you do go there, you have the option to study 1 semester in each university, and the final semester you can do a thesis in the university of your choosing. And if you do finish this course, you get 3 master's degrees. And I've included the course curriculum here. And in the initial slide, I had the web link to all the universities. So, the students can actually go and research and then have a pick. That was my final slide. Thank you for your time.
Yeah, thanks a lot, Dr. Ritesh. You have given very useful information for students of complete all the countries' details in the Europe. I'm sure I've been forwarding students' mails to you many number of times. Now you may get many number of mails from other students also. Hope you will respond such emails. Thanks a lot for joining us.
Thank you very much.
Next speaker, I invite Professor Rajiv Ganguly. Professor Rajiv Ganguly has joined almost an hour back online. Are you there, Professor Rajiv?
Yes, I am.
Yes,
I am.
Yes.
Can I get control, or are you flipping the slides? Okay.
If you want, you can share now. Ritesh, can you stop sharing your screen? Professor Rajiv Ganguly doesn't need any introduction in mining economics around the globe. He is a very well-known figure. I think our director is online, Professor Umamaheshwar Rao. You know him very well personally. And in fact, chief guest also still online for last 2.5 hours. Professor Rajiv Ganguly graduated in mining engineering from Osmania University. Then he moved to US. He did MS in mining engineering from Virginia Tech, Ph.D. in mining engineering in University of Kentucky in USA. After working in industry for a very short period, he joined academics. Most of us know that he was earlier heading the Department of Mining Engineering at University of Alaska Fairbanks. He is the first generation mining faculty, as per my knowledge, who talked about soft computing system like artificial intelligence and all these things. He started around almost 15 years back, if I'm correct. And he has done a number of projects, almost $12 million worth projects have completed, and many projects are on, in hand. Recently he moved to University of Utah as a professor. He is recipient of many awards like Alaska Innovators Hall of Fame, Rockstar of Alaska, Fulbright Specialist, Flame Safety Lamp Award, State of Alabama, Robert Pillay Award from Society of Mining and that is SME, and he is on the editorial board of SME Journal also. Most of the mining engineers and most of the teaching faculty like me, we are aware. Very happy to see you, Professor Rajiv Ganguly, after a long time. You can start now.
Yeah, thank you very much. Can you hear me?
Yes, yes.
Fantastic. Yeah, thank you for the kind introduction, and it's quite the honor to speak to this group, and I was listening in. I have to leave for my university soon, so I was in and out, but yeah, I really appreciate the opportunity. So this part I don't need anymore, and so I will just skip that. And I'll talk a wee bit about University of Utah, and then we'll go from there. So this is the campus. I love it. I just was hiking somewhere here just yesterday morning, early morning hike. But yeah, University of Utah is a comprehensive state university. So state university means it's funded by the state. It's in Salt Lake City, and according to our president, the other day, she said there's only about 20 universities like ours in the U.S., and that is because we offer everything from medical school to engineering, sciences, arts, all kinds of stuff. Most other universities offer some or the other, but not all of them. We have about 33,000 students, about 3,000 are faculty, and half of them are tenure track. And so this is a trend happening in the US, less and less tenure track faculty. The university annual budget is about $5 billion. And the reason I'm mentioning this is because there is a theme throughout that you will see. So we are a state university, but like in most states, the state support is really very little. 5% comes from the state. So the rest come from other sources, and you will see why the rest of my talk is the way it is. And the research expenditures are about $600 million a year. And so as I was debating this talk, when Professor Ramchandra asked me to talk, you're always tempted to give a sales pitch because that is always very uplifting. On the other hand, I'm talking to students, and the students have a lot of energy and enthusiasm, and it's really good sometimes if they get to see the whole picture. So I will present it perhaps a little bit differently than some of the talks that I heard. So one thing Professor Ramchandra wanted me to cover was the cost. And so cost, you can see it's about $50,000 a year as a non-resident student, so about 30,000 in tuition, living expenses about 14. You can see this. So I will not dwell on this one. And so this is about right. And so when you share your room and board, perhaps it can be a little bit cheaper, but some of the other costs remain. So, all right. I really wanted to start with this systematic difference. And the reason is I receive, like many other faculty members in the US, Canada, and perhaps other places, requests for different things. And students, all of us approach life from our own experiences. And so some of the things in the US are quite different from India. And one of them is the regulatory requirements. So just this morning, I confirmed again from my WhatsApp group, a bunch of mining engineers in India, that yeah, there is a, like the regulatory requirement that you have to have X number of mining engineers for Y amount of production. And then depending on whether you're in a gassy mine or not, so on and so forth. So there's a link between production and mine conditions and jobs, mining jobs. Here, there is none. So you will find there's very, very few mining jobs, mining engineering jobs in the U.S. And so as an example, I used to work at Jim Walters. We did 6 million tons of coal. It was a highly gassy underground mine. We had maybe 4 mining engineers. And we had 450 employees total, including the wash plant. So what happens is, because there's so few mining engineers needed by law, there's very few mining engineers. And so here, the mine engineer title is given to anybody that is helping with the mine. It does not necessarily mean they have a BS mining. And so what happens is the university departments then are smaller. And so when you look in India, most mining departments at universities have perhaps 10 to 20 faculty members. In the US, a more honest number is perhaps 5 or 6. And some universities are clever. They will combine their metallurgy and nuclear and this and that and make the department look pretty big. But they are not. Their mining group is perhaps 4 or 5 people. And metallurgy in the US often means material science. And so they're really not in mining as much. So, and then here, I just thought I should mention, we produce maybe 250 to 300 BS mining engineers per year in the US. Compared to civil engineering, civil is perhaps 12,000 a year. Petroleum used to be 5,000, it's probably less. So correspondingly, there's very, very few faculty jobs available. All right. What's the other one? The other side is the role of mining in government and economy. So when you look at the US economy, it's a $20 trillion economy. Mining GDP is less than 1%. So society really has no interest. They're not aware there's a mining industry. And if they are, it's usually not a good thing. They're usually anti-mining. There is no CMPDI. There is no National Institute of Rock Mechanics. These things don't exist here. There is NIOSH. There's a small amount of, they do a very tiny bit of mining safety related research only. It's directly related to safety. And that's it. So from a federal perspective, which is your central government, there's really nothing. U.S. Bureau of Mines is long gone. NIOSH, does a little bit. States, as far as the state governments go, they barely manage to regulate whatever few mines they have. So states provide no resources. Okay. So this is your overall, system. So within this, when a student sends and says, "How many lines of PhD do you have?" I don't know whether I should laugh or cry. Because there is no base funding for, nobody says, "Hey, go give 10 PhD awards to students." Okay, so there's very little base funding, and you give it out, but they're usually gone. There's maybe money for 1 or 2 students. Some may have 3 students, base funding. Now after that, really all assistantships are funded by professors. So I am about to get $1 million grant. I hope it'll come through. I'm expecting it today or perhaps Monday. But you get money, then you hire. So I've already interviewed students from around the world. Zoom is a wonderful thing, and I'm giving out, right? I'm picking up a student from Africa. So funding. So when that money disappears, that line is gone, right? And so I have a postdoc, I have a graduate student, and all of this are usually funded by faculty with their own money, with their research money. And by the way, did I tell you there is no research agency, right? So it's incredibly difficult subject here, funding a student. And you saw the cost of a student. To pay a student, it's about $70,000 to $100,000 a year, depending on the university. So it's very expensive to fund a graduate student, $300,000 to $500,000 perhaps. Okay. So prospects in the mining industry. Okay, so you're lucky you got an assistantship. Should you come to the US? Okay. Here is another thing. Okay. Industrial experience is essential to jobs. So in India, there is a cultural advantage to getting degrees upon degrees. It's people think you're smart. It's liked. Here, it's the opposite. If you have too many academic degrees, they assume you're avoiding work. Okay, it's considered very bad. So the worst thing you can do to your credentials is to get a BS degree, then immediately get a master's, and then immediately get a PhD. That is the key to unemployment in the US. So if the best advice, I see this again and again, whether they're students from Brazil or Africa or India, or certainly in the US, after a bachelor's degree, work for 3 to 5 years before you get a master's degree. When you're getting a master's degree, work at the mines, work with your advisor and say, "Hey, I want to apply for internships and I want to get it." Most of the time, a good employer is going to, if they like you during the internship, they will not let you go. You will have a job on the day you graduate. It's a starkly different experience versus if you came in without job experience. Don't get a PhD. You're not going to get a job, not with the mining industry. It's very rare. I mean, I'm not saying there are no absolutes in the US. I have seen companies say we have no jobs available, and then they like somebody and then they hire them. So no absolutes. The other thing is personality is key. US is a country where Obama became president because he could talk. If you can talk nicely, make people comfortable, if your English is good, if you can talk football, you're in good shape. So personality is key. How about academia? So you want to be professor. Well, you know what? It's nearly impossible. So I would almost say forget about it. Prospects are shrinking. When I came to the country 25 years ago, there were a lot more mining schools than there are now. You saw the system we are within, right? And so that's why we don't have mining schools. Universities say, why should we fund a department with only 20 students or 30 students total, right? So departments have shrunk. So when we hire for positions, and University of Utah has been hiring and will probably continue to hire. So we have been a bit unique, but 70 to 100 applicants for a job. And I would tell you, most are quite good. They all have industry experience, typically 3 to 5 years. They have fantastic PhDs. They're from all the schools, the good schools that you know of. Most of them have rock mechanics because every government other than the US, right, they're funding rock mechanics research. So there's dime a dozen, right? Ventilation, same thing, dime a dozen. Mineral processing, that, right? So they all look the same. Everybody has published some papers. So recipe for success, how do you float up? You have to have a record of success. You have to bring in money. That's it. And so because state funding is 5%, remember, so they lack money. So we want faculty that can help the department, meet its mission. And so we need faculty that can support that. And so a record in a foreign country may not translate because, in some countries, there's a lot of government support for education. And so they get tons and tons of research money. And so we look at that resume and say, well, can you do that in a country where you really have to fight with everybody to get money? So, all right. Prospects in the US, general trend. US is hot. The economy is booming. Even with COVID, it is crazy. So it's very interesting. The mining scene is quite depressing, but you just step back and you say, what's the prospect? It's booming. So, technical skills are actually not that important in the US compared to computer science, because what happens is in a university, you're getting 50 different skills. And most of them are not directly applicable to a job. They help you learn how to train yourself and things like that, right? And so it's the personality, your ability to work with others, ability to learn because you're constantly learning. So these are the things that are very, very important. And this is why I tell students, don't define yourself as this or that. You're not a mining engineer. Mining is something you also know. You also know math. You also know how to communicate. You can take a complex idea and explain it to somebody. And so it's those other things. So, if you have that attitude, then it's very easy to find a place here. But the other thing, is it's perhaps one of the most productive countries in the world. For a country that big, it's amazing how uniformly everybody performs. It's long hours. Everybody's working hard. Very few people take their vacation time fully and properly. So people are working. I send emails out at midnight and I'll find somebody on vacation. Yesterday, I was dealing with US Department of State. I happened to call one of our university staffers. I didn't know he was on vacation. He completely helped me out. We are expecting 1.2 million. And so for 1.2 million, all of us are dancing. So vacation or not. Job security is less. You can get fired anytime. And so people are constantly upgrading skills. So it's interesting. Technical skills are ranked not that high because you're always learning something new. You have to do something new. My brother is in the tech sector. They work 12 to 14 hours a day, every day, 7 days a week. So, and pay can be quite high for successful people. So, all right, some technical trends. Let me start with BS mining. So this is what we offer our undergraduates. Computational intelligence, you can take it at undergraduate level or graduate level. Unmanned aerial systems, again, the drones and all that, how to use them for various things, because drones are pretty standard in mining. systems engineering, again, production optimization, things like that. And then we offer at programming and mine design software at the freshman level, because really by the time they go to internships in the summer after the freshman year, we want them to be able to help their employers. So interns usually make $20 an hour, and so employers are looking for real skills that can help. Areas of interest in mining, there have been several high-profile dam failures, and not just in Brazil. So zero tailings is something you hear a lot around the mining companies. The other thing you hear, of course, is data and AI. These are, data and AI is all aspects of mining. So it's not this or that. It's everywhere. I've been doing AI for at least 25 years now, and I've been teaching it for about 20 years. And, I have seen it go from academic papers. So when you look at mining, it's mostly academic papers, some professor doing some ore body modeling ad infinitum, right? And so we were smart. We learned the phrase machine learning 20 years ago. And so there's a whole bunch of machine learning papers that are purely academic. But that has gone from purely academic to actually mining companies. Now they're starting to think about these. And I've been talking to a lot of mining companies and interacting with their teams, how to deploy these things in real life. The biggest issue is sensor quality. The data just isn't there. So, so you're seeing production systems in the PI systems in processing plants. You might have, like our faculty have research with, for geotechnical type of stuff for monitoring. And then one thing that I'm doing now, I was previously helping develop some technology for Sumitomo, and now I'm into mine safety and health systems, and I'll talk about that. So typically, they're used to predict failures, when will my shovel fail, or when will my slope fail, or you use it to optimize. And so like some of the things you see now, we have always had belt cameras, but now the camera images, it gets translated into particle size, and particle size might go into your optimization system. So flotation cells now have cameras, right? And LiDAR is pretty mainstream. So people have been using LiDAR for 10, 15 years, at least in mines, at least 10 years quite intensely. And back in the day, it used to be about avoiding the surveying, so you don't really see people carrying your survey instruments. So they just LiDAR it. But it has actually gone from that. Now it has reached a level of maturity. So now we do stockpile management. And so large mines, they will have 2 to 3 days worth of stockpile. They're managing that using the LiDARs, and they'll fly a drone about it to get the 3D volumes and look at how the material is flowing. The other thing that happens in underground mines is stope monitoring. So a lot of the voids and how is your stope moving, monitoring sub-level stopes, because stopes are getting bigger and bigger. And so one way to...
Sir, Rajiv, try to conclude, please.
Yeah, all right, sounds good. So this is what I'm doing, okay? I'm almost done. So mine safety analytics. So, we have now companies that will give out apps to their employees. You go, employees make comments, hundreds of comments come around. And, what's happening in the mine from a safety perspective. So I was able to tell this app developer, they have 11 or 15 customers, and I was able to tell them what problems they were having. Like one particular mine, they had a major safety issue. So it's a leading indicator. Same with, I'm working with NIOSH on analyzing safety incidents, is the MSHA data set. So you look at text like this and you say, okay, what is the analytics that you can do? And you find patterns. So like my algorithms will tell you that, it was a caught fire type accident. These were the equipment involved. These were some details. And then you can do analytics on it and, do warnings, etc. So industry really, from a research perspective, industry wants products. They really don't want research. And this is always a challenge for us. Technology, AI, all of this is opportunity, but there's also big players. You're competing with billion-dollar companies. Sometimes I'll give a talk and I'll see Microsoft in attendance, right? And so these guys are scoping me out and seeing what I'm up to. So It's very difficult for academics to break into this, and it's a struggle. But my advice to industries, trainer, analytics people, I really don't find that all the applications are successful. Big companies, they jump into mining analytics, and they don't know anything about mining. I feel it'll be better if analytics is done by the mining people. So with that, I'm done.
Yes, thanks a lot, Professor Raju. You have given a very good comparison between India and US academics, industry, and research. Yeah, we are fully aware that you are a very strong researcher. We wish you all the best. Many of the questions put in YouTube already you have answered. Thank you very much for joining us. Soon we'll have an online meeting with you, with my faculty and my director soon. I'll contact you later. Thanks a lot.
Well, thank you. Thank you. Bye-bye.
We have come to the last speaker. Exactly, we have 29 minutes. After that, our online link will end. I invite Dr. Mo Momais. Dr. Mo, you are there?
Good morning.
Good morning. Welcome.
Good evening.
Yes. Dr. Mo Momais is presently head of the department at the University of Arizona, Tucson, USA. And basically he did his BS in geophysics, MS in applied geophysics, Ph.D. in mining engineering, all the degrees from McGill University. He has been working in mine ventilation, geopositioning, data analysis, rock breakage, heat stress evaluation, published more than 125 papers. I'm surprised to know that he has filed or already granted 14 patents. It is really surprising for me. And he has 3 startup companies. I visited him a couple of years back, and he has taken care of my visit when I visited this university. And I think he is joining with his team of international office of the university. I welcome Dr. Mo. Please go ahead. This link will end exactly after 28 minutes. If by mistake it ends, I will call you later. Otherwise, we will have a word to say bye.
Thank you. Yes. Thank you very much. I'm Momo Mayas, interim head of the Department of Mining and Geological Engineering. I really would like to thank Professor Chandler and NITK for providing this opportunity to introduce University of Arizona and the mining engineering program to all of you, great students from India. I would like to say just a few words about the University of Arizona. The university is part of a tri-university system under the governance of Arizona Board of Regents. Together, our university with Arizona State University and Northern Arizona University enroll more than 158,000 undergraduate students and more than 195,000 students together, including grad students. And we confer more than 33,000 undergraduate and graduate degrees annually. The university has a very strong reputation in hydrology. That program is ranked #1 nationally. Optical sciences ranked #1. Our program, mining engineering, is in the top 3 in the US. Geoscience is ranked #4. Management information sciences ranked #4. And many other disciplines are in the top echelons. Okay. So for the past 135 years, the Department of Mining and Geological Engineering has been the state of Arizona's sole provider of academic and research programs focused on mineral engineering and the science of non-renewable resources. Throughout all this time, our department has been responsible for some of the world's most dynamic innovations in mineral resource development. We have contributed to the state of Arizona's present position as the nation's most valuable non-fuel mineral production center. Today, our department offers an ABET accredited Bachelor of Science in Mining Engineering, So as you can see, this is actually the first and oldest degree program at the University of Arizona. We also offer certificates, Master of Engineering, Master of Science, and doctoral degrees in mining, geological, and geophysical engineering. Our department has the largest endowed scholarships in the College of Engineering. Only last year, we awarded more than $400,000 of scholarships to undergraduate students alone. So in terms of graduate degrees, Master of Engineering is a 30-unit degree program, all coursework, no research. It's extremely flexible and dynamic for working professionals as well as students who seek a change in career. So here you can see the breakdown of the units. So I'm not going to go through every one of them in the interest of time. We have several emphasis areas in geomechanics, in mineral processing, mine health and safety, sustainable resource development, mine information system, information and production technologies. On the research side, Master of Science, it's also 30 units, but it includes 6 units of thesis research. On the doctoral side, on the Ph.D. side, it's a 66-unit program, 36 units in the major, 12 units in minor, and then 18 units of dissertation. I would like to say a few words about our department and the faculty. We have 16 permanent, adjunct, and emeritus faculty in MGE who teach a wide range of undergraduate and graduate level courses, which basically covers the life of mine cycle. Our faculty have extensive and in some cases, I would say unequaled expertise in many areas such as exploration, mineral economics, site characterization, geomechanics, sustainable development, geotechnical engineering, mine health and safety, rock excavation, blasting, surveying, ventilation, surface and underground design, mine power systems, mine reclamation and remediation, tailings design, mineral processing and comminution, in situ leaching, hydro and pyrometallurgy, geophysics, mine automation, artificial intelligence, and machine learning. So as you can see, we really love what we do and are involved in every possible avenue of research and exploration. Our university owns and operates the only multi-level underground mining laboratory in the US with a working vertical shaft where our students run the mining operation. So over the past 15 years, over 10,000 industry professionals have received mine construction and health and safety training at our facility. The San Javier underground mine has long been a training and research resource for federal and state agencies, as well as organizations devoted to underground research, tunnel safety, mine rescue. A lot of speakers this morning, they talked about the Internet of Things and the fourth industrial revolution. I'm really happy to share with you that our facility is at the forefront of the fourth industrial revolution. So we have high-speed internet connectivity underground. We have networks of wireless sensors that monitor and stream data in real time about everything underground from the mine environment and mine workers. So the data that comes out of these sensors are used by students and by our researchers to learn more about the stability of underground openings, ventilation on demand, the effect of diesel particulate matter, fatigue, and heat stress and safety. So I'm going to do a quick demo, if you allow me, just to show you that we have a connected mine. So I'm going to log into our portal. So this is a 3D block model of our San Javier mine. Students in my geopositioning mine surveying class survey the mine using a couple of LiDAR systems, and they learn how to create a 3D block model. So this is the work of students in my work. So the block model you see on the screen. So if I may just quickly log in. I did have a slight problem earlier logging in. Hopefully it will show up. So in the meantime, I'll keep talking. I'm really excited to share with you that a couple of weeks ago, our mine began a major expansion project through a grant and financial support from the industry. Okay, so here it comes. So here you see data from several sensors underground. We're currently, I'm showing airflow. I'm showing the displacement in the rock in the decline, in our adit, and at the 150 level. And we're also showing, I'm showing an airflow in the 150 level. Just to give you an example, click on the data tab. Here you can choose the time of the year and the type of sensor and the location of the sensor, or the level at which the sensors are installed in the mine. You can grab the data and use it for research and teaching. So we can access the data live, or we have access to a historical record of the data for the past. We've been doing this since 2017. So for the past 3 years, we've been kind of at the forefront of the Internet of Things and connectivity. I apologize for this. Let's go back. So yes. All the design for the expansion of the San Javier mine has been carried out in-house by our technical staff. However, during the year-long construction period, the underground mining lab will continue to provide learning opportunities for students, and community use will also continue. For example, first responders use the narrow winding tunnels for search and rescue training. We have Border Patrol who come and train at our mine. There is active research from more than 15 external clients at the mine. So all of these activities will move forward during the construction period. We've been a leader in the online mining education space in 2008 compared to other mining engineering schools around the world. We've been offering all of our undergraduate, graduate, and professional development short courses, both in person and fully online, for over 12 years. Our lower division mining engineering courses are streamed live to a couple of community colleges located near, for example, located near Morenci mining operations. Morenci is one of the largest copper mines in the world. Next year, we will expand our lower division course offerings to another community college, Cochise County, which is at the border with Mexico, in full live online modality. So the students from these two community colleges can enroll in the Mining 2+2 program and will earn a BS in mining engineering in 2 years after transferring to University of Arizona. Our Master of Engineering degree is shaped and taught by our expert faculty for professionals in mining and mining-related fields who seek to further their career in the mineral resources industry or to develop advanced skills for the real world. Our virtual courses are built on the same rigorous curriculum as our nationally acclaimed on-campus programs. We provide a flexible, interactive learning experience. Our mining engineering online classes offer students access to practical coursework and engaging learning materials from anywhere and at any time. Over the past 10 years, hundreds of industry professionals from all continents have participated remotely in graduate and professional development courses offered by MGE. A noteworthy event in 2015, our department developed an online executive mining program called Mining 360 for Caterpillar. So as everyone knows, Caterpillar is the world's largest mining equipment manufacturer. So to date, since 2015, over 55 Caterpillar executives, managers, engineers from around the globe have completed the one-year-long 9-credit graduate certificate program. So building on the success of the Mining 360 program with Caterpillar, next year we will launch a 7-week online curriculum, Mining 4.E, for Hexagon mining employees. We will be implementing some novel learning tools such as virtual field trips, auto-graded quizzes, and e-interviews with industry professionals. So the Mining 4.E program will provide students a solid understanding of mining processes, including ore deposits, mine valuation and economics, mine planning and design, operations, and safety and risk management. So, University of Arizona is located in Tucson, and Tucson enjoys a very special status as the hub of mining technology worldwide. Here we have the headquarters and offices of many iconic international companies such as Caterpillar, Komatsu, Hexagon Mining, and many others. We are surrounded by multiple world-class mining operations. We have all the components of a world-class education and innovation ecosystem with the university, technology transfer, industry, government, and civil society. Our faculty are extremely active in research and technology transfer with dozens of invention disclosures and startup companies since 2015. This really reflects the cutting-edge nature of the research conducted in MGE, and it really involves collaboration across colleges on campus and the industry, the mining industry. So in the interest of time, I think I'm gonna turn it over to Professor Chander, and if there are any questions, but before I do that, I wanna introduce our recruitment and outreach coordinator, Mario Munoz. I don't know if he's online. If he is, I would like him to say a few words. If you have any questions, feel free to reach out to Mario. His contact information is on the screen. And since this webinar is recorded, you can refer back to this slide. Is Mario online? Okay, so
No.
He's not. That's fine. So here again are my coordinates, my contact info. In case you have any questions, I'd be very happy to answer any questions. How are we doing for time?
Yeah, thanks a lot, Dr. Mo, for joining us and giving a detailed information about your academics and about the surrounding industry in general. Thank you very much. And any questions, because many of students also there in MS teams now, our own students, and many speakers are there still with us, including chief guest and director. Students can ask any questions now. In fact, one of our students graduated from your school from Tucson when Professor Kultilke was head of the department. I referred him.
That's right.
Yes, he was extremely happy to be with you.
Thank you.
Yes. Any questions? So there are some questions on YouTube. Dr. Mo, what is the opportunity for our research scholars to do postdoctorate with you for a 1 year or so?
I think that there is 1 or 2 positions that might be available. You need to, I'll be happy to share the information offline. You need to contact the faculty. It's mainly in mineral processing and hydrometallurgy.
Okay. And any opportunities in the core areas of rock mechanics, slope stability? Of course,
we have several. Yes, we have several faculty who are extremely involved in that area of research. I should have mentioned we have a geotechnical center of excellence, which provides opportunity for people to do research, for students to do research at the master's and graduate at the doctoral level. So feel free to contact me. I will put you in touch with the right faculty. There are quite a few projects going on at the Geotechnical Research Center.
Sure. Thank you very much, Dr. Mo. And I thank everyone, all the 6 speakers and our director and all the participants for joining us. Tomorrow early morning, early means around 9, exactly at 9 a.m. Again, we'll meet as per IST time. The first speaker is Simit Rawal from University of New South Wales. He is also late night for him. Still, he is on live with us. Director, sir, can you say anything? Because we have only few minutes for our link. Okay, any other questions from any participants? And some faculty members are there. If you want to say anything, you are welcome now. Last few minutes. Many of our PhD scholars are there. You can pose any questions to Dr. Mo or Dr. Ritesh is here. And Professor Krishna Reddy is there still.
Dr. Ramchandra?
Yes, sir.
It was excellent. All the speakers gave a lot of information, and then I feel it definitely go a long way for the participants, especially the students, the scholars, and also to plan their career. It is very excellent way they presented. I hope tomorrow also they will attend full, and then it will be definitely useful for them. Thank you.
Sure, thank you. Professor Jayantu, anything is there from your end, sir? Anyhow, you are speaking to people tomorrow. You have a presentation. Then we'll close the session. I thank everyone. It is a very good response and excellent presentations from all the 6. And good presentation, good speech from our own director. I thank every one of you. Tomorrow we'll meet again at 9 a.m. as per IST Indian Standard Time. Good night to everyone. I'm closing the link. Thank you one and all.
Thank you, Dr. Chandra. Really appreciate the opportunity.
Dr. Mo, again, I'll contact you. Thanks a lot.
Thank you.
Sure.
Okay, bye.